connect.
Future is watching. Welcome to OPCODE Virtual Summit.
Hi, and welcome back for a new episode on OPCODE livestream. Glad to be back again. So we have some cool speakers, as you probably have heard right now. But yeah, so that should be like pretty cool. Let me just show you what we're going to be talking about today. So let me retrieve the agenda. So the agenda today, so we're going to have Grok, who's going to be talking about crime ops, so the cybercrime operations, as you can guess from the name. We're going to have Corentin and Paul from Synactive. We're going to be talking about the Windows 10 pool, so it's a refresh of a lot of the existing research that was done in the past. So that should be like quite interesting. Especially with a lot of the modifications that were done on the pool manager on Windows 10. And the last presentation is gonna be me, actually. Just so people don't think I just like present stuff on YouTube. I'm gonna be talking about my revised version of SMP Cost. So because I have an ARM64 Windows laptop and I wanted to learn ARM and how to write a remote code like an RC exploit. I was like, well, actually, that's a great excuse to learn both at the same time. Yeah, so, and don't forget, so yeah, all the information are on the website on opcode.com. And don't forget to subscribe. If you're watching on YouTube, it definitely makes it much easier whenever we keep publishing the videos usually after the stream, which happen every 2 weeks. If you're not familiar with it, we push like the videos like the following days, although the full stream is available. And I also started a Spotify podcast, so I'm taking a lot of the mainstream discussions that we have, that can be listened, by non-engineers and cut them into like some Spotify episodes. So that's also quite interesting. If there is also like any guest, that you would recommend me to have in the future, please do not hesitate. Discord, we're always there. That's quite crowded actually. Like I'm quite surprised. Just like now, as you can see in the top corner, there is 70 people who are like online now, and yeah, you're more than welcome to join it. And for the materials, so we cannot see, but my chair actually. Yeah, you can just go at this address. You can just go at this address, so that's where we're gonna keep pushing the slides and the materials. Yeah, that's pretty much it for the agenda today. Anyway, I will see you after the presentation of our next speaker. So yeah, so if you want to share your screen now, Grok, and get ready, you're more than welcome to. As I will put the transition video and everything. Yeah, and the next dates actually for OPCODE that I didn't mention here. So the next OPCODE is gonna be on July 15, and the one after on July 29. And if you want to speak at the conference, the call for paper is on the website, so you just need to click on call for paper, and that's pretty much it, so that's quite good. Yeah, well, I'll launch the transition now.
The future is watching. Welcome to OPCODE Virtual Summit.
Hey, all right. So I'm going to be doing a business talk, which is tangentially related to cybercrime, because cybercrime is a business. So this is going to be about crime ops. It's the operational art of cybercrime. So basically, this is going to be covering Fin7. They have been operating for like 5 or 6 years. They're currently being dismantled, like the executive suite is being cleared out. And this is interesting because in the process of doing that, the indictments that have been released for the like the head management have included a lot of the operational details of how they managed their team, which is something that is very rarely visible to an external researcher. Typically, the internal management of a group is very, very opaque. So here is a wonderful opportunity to actually see how a highly successful, by the metric of getting money by crime, how a highly successful group ran their operations. So we'll be just covering slightly sort of about business. Then we'll look at Fin7 using several analytical frameworks, which we'll introduce during the business section. In particular, it's the people, process, technology triangle. Then I will discuss the operational art as they've actually developed it, and then we'll have a lessons learned. So you can take away the key insights for running your own cybercrime group. So the first thing to start out with is, like, Fin7 is super lame. If you're interested in a really cool, exciting, like cutting edge group that does really awesome stuff, like Fin7 is not your group. They are boring as fuck, right? So their tools, techniques, and procedures are like straight up generic. So, you know, they use spear phishing, then they use malicious documents, then they use a derivative generic malware. Then, so like they gain access with spear phishing, which, you know, so does everyone else. They get execution with a malicious attachment, which, you know, so does everyone else. They hang around using generic malware. Like, to be fair, theirs was quite good for the era, but, you know, it wasn't a custom bottom-up super cool implant. It was just malware that anyone had. The way that they do their collection is like sniffing the wire. At some point they had point of sales implants, and they do network and system reconnaissance. They just look around for stuff. And then the way that they exploit their victims, that is the way that they actually gain value from that attack, is wire transfers using their financial information, or they sell data that they steal. So they'll steal financial data such as credit cards, debit cards, and they will sell that. So, you know, stop me if you've heard this one before. Like, this is as cookie cutter, straightforward, like bread and butter, meat and potatoes. This is not very exciting stuff. This is a very, very boring group, which is why they are amazingly fucking innovative, right? So what's fascinating is that having that very, very top 10 OWASP set of procedures for gaining access is what allows them to innovate at a more interesting level that generates much more revenue for them and allows them to be more successful. So the important thing is, like, they're not technically innovative, right? They're not pushing the envelope. They're not really doing anything super exciting, right? If you wanted to, you could spend an afternoon on GitHub and you could have the exact same capability as Fin7 from top to bottom, right? Like you can download your way to parity with Fin7. They're not really that exciting. Also, they are not strategically innovative, right? They basically hit the same stuff that everyone else does. They monetize in the same way, right? Like they're stealing credit card data, they're doing wire transfers, they're not doing anything special. So that leaves only one arena where they can do innovation, and that's at the operational level. And this is fascinating because operational innovation is actually one of the hardest and rarest types of innovation to see in a group, particularly one that isn't, they don't have business consultants helping them out. So that's sort of like the high level overview about Fin7. I'm not actually going to spend a lot of time talking about details on them because it doesn't actually matter for what we're going to be looking at. What we're going to be looking at is business, right? Because cybercrime is a business and business is good. And when we discuss businesses, we need to have at least one analytical framework that we're going to use to analyze the target so that we know what we're talking about. So in this case, I'm going to use essentially a primary analytical framework and a overarching set of levels. So we've got like the strategic, the operational, and the tactical. At the strategic level, this is how you implement policy, right? So if your policy is, we will do cyber crimes, then your strategic level stuff is, how are we going to do cyber crimes? If there was a grand strategic level, it would be, should I do cyber crimes or should I do something else? Right? Like that would be you would define your policy higher up. Once you've got your policy, then you figure out how you're going to implement that and what objectives you have to ensure that you're executing well. Then operational is basically how you go about actually accomplishing those things. And that's in terms of managing the tactical actions sort of underneath. So your tactical stuff will be grouped together into like operations, right? Just bundles of tactical actions. And then operational is the level where you manage all of that. You've got like the resources, the ways that you get one operation to support another, which people you assign to which thing. So strategic, operational, and then tactical, which is the actual like nitty-gritty of how you go about committing your cyber crimes. So in terms of an independent researcher, a separate research thing, typically tactical innovation, not only is it relatively fast, it's relatively fast to discover, because when people start doing something like technically new and innovative, as soon as it gets discovered, bang, that's it. You've found tactical innovation. You found like this new thing that they're doing. Strategic innovation, that tends to be a little bit slower, but it can be discovered sort of over time with new trends that start showing up and sort of longer, more in-depth research to see what people are now doing instead. The thing is, operational innovation, it's very, very hard to see, because the only way it shows up is when the tactical game is on point and they're executing well on their strategy. Right? It's opaque if they have good internal processes and excellent technology and people, and they are running an efficient, tight ship. You won't know that, because that's not something that shows up in any forensic artifacts, right? That's not something that gets left behind and leaves fingerprint. Those are the three levels. Just to give some examples of like what a cybercrime strategy would be stuff like when you have a new monetization method, when you have new ways of doing monetization, this can open up new revenue streams, which is very useful because there tends to be a lot of competitors. And these competitors, if they're using the same monetization methodology that you already use, basically they will, it's something of a tragedy of the commons. Basically, they will eat up all the resources and you will have, less money for yourself. So finding new revenue streams is always good. And sometimes a tactical innovation, like a new technical capability, can open up a new market for exploitation or a new method of monetization. For example, ransomware was a strategic move that created new revenue streams. Crypto miners are a strategic move that create new revenue streams. So, like these are the broader strategic things that can happen. But that said, sort of lower down, you have your tactics. So the tactics are basically your malware. As I said, like ransomware, crypto miners, things like that, which create new means of doing monetization. But also, if you have a really good high stealth malware, you can have longer dwell time, which gives you a longer period of exploitation. So you can, make more money from one victim by simply being on that network for longer. And, it doesn't need to be technical. It can also be just a pure tactic. So the move to extortion, which, ransomware was already extortion. It's, it goes and it hides people's data, right? It's going to destroy data. But people actually care more about, having their data go out to the public than they care about getting access to their data again, generally speaking, of course. So if, you really did want to make money, you would replace all of your ransomware with threats to publish, everything that you can find on the box. So I wrote about that a while ago, and anyway, it's interesting stuff. But it's, like it's a tactical change, and it allows a business to adjust how it's making money. And then at the operations level, this is the stuff that we don't tend to see, right? So it's just managing the resources and infrastructure, doing support for the infrastructure for exploitation, right? So, making sure that you can still sell your credit card data to people, or making sure that you have access to someone who has money mules. It's really not interesting stuff. And again, it doesn't show up in a postmortem analysis from the outside, because this is not something that is visible unless you have complete and total access to everything. And so it's interesting to see it when it's innovative, and it's hard to see innovation in the wild. So support, management, tracking progress, making sure that things are happening in the right order so you still get your money. And then after something falls apart, you're going to have to do lessons learned, like what went wrong. Then once you say like what went wrong, then you try and integrate that into your understanding of the world. So you do sense making, and with that, you sort of update your assumptions and you add new knowledge. And then the next time you have an operation, it will be better, right? That's the theory anyway. So this is operation stuff, but it's also not something that you will see unless you have amazing access. And it's not something where innovation is obvious. So what's cool is because we do have this access to Fin7's internal operational management and how they ran their business, we can see how the fuck they innovated, and it's really cool. And in order to look at that, what we're going to need to do is talk about business analysis and the PPT framework. So people, process, technology. It's sometimes shown as Venn diagram. Typically it's shown as a triangle, but I couldn't find one to steal on the internet that was high enough resolution. So you get to see the Venn diagram. But the important thing is just to know that these three components sort of interact, and they are what enable your business to improve and to execute on your strategy. So people is basically, you need to have the right people following a process that works, and then technology is used to make that process more efficient and to optimize the workflow of those people. So the idea is sort of like if you look at a business, you can look at who they have and how those people are structured and managed. You can look at what they do, and you can look at sort of how they do it, and then what technology they use to enable that. And that can tell you sort of like what needs to be improved, or how this particular thing operates and functions. So with Fin7, just a brief run through of what they have. They have multiple job roles. Each job role has its own set of responsibilities and areas of concern. They basically have an executive suite. They've got these managers. These are the guys making the big money. Well, actually, the mobsters that they paid off probably make more money. But anyway, so you've got your executive suite who sort of run and manage things. Then some of them are sort of on the cusp. They're support. So they help the managers and make sure that things work smoothly for the frontline workers. And then, they have frontline workers. And the frontline workers are the people that we tend to think of when we think of cyber criminals, which is, like the hackers and the malware writers and stuff like that. Then, okay, so Fin7 has got this process, and the process is pretty good. It's this OWASP top 10. It's this cookie cutter thing that we went through. Basically, you feed a company in, and you run your process, and at the other side, money comes out, right? That's what you want. You want a process that just works. And that's almost anyone, or at least people that you can hire, can follow and execute, because at some point you're going to have to, grow and expand so that you can make more money. So they have this process which allowed them to make money from basically any victim that they targeted. They also use DevOps because their developers were also running a lot of the infrastructure and were directly interfacing with the operators who are doing the hacking. So they would be able to update and give them like new tools and add functionality and things like that as operations were going on. And interestingly, they basically used Agile. I don't believe that they had daily stand-ups, or they had a Kanban, or they did user stories. I'm a bunch of credit card data and I want to be stolen. Now, I don't think that they did that part of the Agile process, but what they did do is very, very rapid iterations of very small feature sets. So they would not do this like, oh, we're releasing an entirely new strain of malware. They're just, bump it by a 0.001 version release. So something that worked, they stuck with it, and they just did incremental improvements as they went along. And then in terms of the technology that they used, they basically just used Jira, which they used for project management, and their projects were businesses that were going through the process. They had a fair amount of coordination, collaboration. So they like had Hipmunk, which I bet I've misspelled. They had an encrypted Jabber, which they used for sensitive content. One of the things that came out in the affidavit was that the encrypted Jabber, like they got logs, the FBI got logs of that, and the FBI tries to sort of like make fun of it a bit, saying, you know, like these guys shared their like real names and bank information and ha ha ha. And here's the thing. There's very, very few ways of actually moving cash money from place to place. And the easiest way inside of a country tends to be via like bank to bank or something like that. It's a very, very straightforward way of doing things. And like, I'm not at all surprised that they just defaulted to something that works and is simple. And, you know, if you're a developer and you're waiting for your salary, you want to just go straight into your bank and know that it shows up. You don't want the guy saying, oh yeah, the check's in the mail, right? You don't want to be dicked around. So Jira, Hipmunk, encrypted XMPP, and email, because there's no way anyone can escape from email, even if you do cybercrime. Okay, so that's a rough overview. We're going to go to a bit more detail because the details are important in this case. So now we're going to do the people, process, technology in detail. So people. The team roles that they had are, you know, as I said, there's an executive suite, sort of this management level that they handle like the big high level stuff and make sure that the operations are working. And this is the area where the innovation happened. So this is actually the cool stuff. The managers are the heroes of the story, right? Then there are the operators who just hack stuff, and you know, they are not actually that interesting because what they're doing is a straightforward, simple process, and it's literally OWASP top 10. It's dull. What is slightly interesting is that they also had interpreters involved, and my understanding is that they would use the interpreters to allow them to target, you know, non-English, non-Russian, whatever, victim companies, so that they would have people who could do, they'd be able to do their emails for their recruitments, and you know, they'd be able to read what's going on when they get into the network and on the systems, and they'll be able to do their OSINT when they're doing their spotting and assessing and stuff. So one of the things I'll bring up right now, because I don't have another good place to put it, when they were doing capacity building and they were building out their team by adding headcount and hiring in new people, they were bringing in operators on false pretenses. So Fin7 had a, apparently more than one, but they had a fake security company, and they would get people to apply to become penetration testers. Then they would take them, they would interview them, and then if they passed, they would give them jobs doing cybercrime. And see, I don't buy that these guys, like these pen testers, didn't know what was going on. Like, they had to know 100% what was going on. And I'll tell you why. There is no way that they thought that these operations were pen tests, because in a pen test, you write a report. No report, there's no fucking way this is legitimate. Any way that you get out of writing a report is almost guaranteed to be criminal. So I'm sure these guys knew what was going on. Like it's not the sort of thing that you can just easily ignore. So I put together, very painstakingly, because I'm a horrible artist, I put together an org chart to show you sort of how Fin7 is structured. Because, again, this matters. It's important to realize that, like, the core members of the group, the people that are making the real money, that are doing the innovative stuff, that are actually critical for the organization to continue functioning, that's management and the support guys, who, I think there was 2 managers and 1 support, or maybe 3 managers and 1 support. So it's not a huge org chart, it's not a massive group at the top. It's a lot bigger at the bottom, but at the bottom, they are literally interchangeable. They don't matter. All they need to do is execute the process that's already been refined and made to work. And then the management team can exploit whatever these guys get access to and actually make money. So, like, the point of a cybercrime business, a cybercrime group, is to make money, right? And, just like any group or any organization, they basically have a remit to continue to exist. So they're going to strive for survival, and they're going to strive to make money. And then after that, anything else is, ideology from the management. But these guys, all they want to do is they want to make money. This is not, politically motivated. It's they want cash. So if we look at the C-suite, like these executives, they have very, very clear, defined responsibilities, right? The most important thing is the money, right? They're in charge of the finances. They're in charge of paying people's salary. They're in charge of hiring and firing, and they're in charge of taking the data or taking the wire transfer stuff and cashing it out. So these guys own the money. That gives them control over everything else. That's where the power is. The next thing that they do is project management. So they assign tasks to personnel. They put people on projects. They control the allocation of resources so that infrastructure, whatever, goes to the right places. Like, that's fundamentally their most important hands-on part of the business in terms of hacking, is focusing on making sure that the people who are doing the hacking have the support they need and the information they need to do their jobs and hack. And then the other thing that they're responsible for is business growth. So, they do, as I said, the hiring, the salaries. They also have to support the infrastructure and the technology stack, which enables their project management and resource management. And I'm not sure on this because I haven't seen how they selected their targets, whether that was left up to the developers, sort of like the frontline workers, or whether that was done by the C-suite guys at the executive level. I don't know. My suspicion is that everyone did it. Like, they were all in it to make money. So there's no reason that they wouldn't get involved in trying to find new places to hack. Then the support guys, who, again, they're part of management. They're sort of earlier, like first hire, not necessarily founders. And their focus is sort of supporting the technology stack, coordinating personnel, and maintaining the operational infrastructure. So, like, these guys are sort of there to make sure that things are ticking along when the guys who cash out the money aren't there to do that. And also to provide support in the background. The operators, right? So these are the guys who actually do the hacking. Again, they have clear, obvious responsibilities. They're sort of roles that they play, and they get hired to do sort of just this. So the important thing for them is gaining access to a target. That's pretty much all that matters, is gaining access. Access. They need to have persistence, but that is handled basically by the malware, right? It's done by the software. It's not really up to them as long as they don't screw up. So their big thing is doing awesome research. So they do open source intelligence research on the targets that they're going after to find out about people within that company that will be vulnerable to manipulation or can otherwise be recruited. Basically, they have to find out who's working there so they can figure out how to trick those people into doing things for them via email. So their big thing is research, putting up like phishing sites or, fake supporting LinkedIn profiles, all that sort of crap. That makes a come on or an approach over email, whatever, more credible. That's it. That's what they do. And then their task is to manipulate people. So primarily they do that over email, but these guys would also use the phone. So they would, send an email and then they would call up and apply pressure to the person and get them to actually, double click on the thing by talking them through it and, hurry, hurry, hurry. And so that's sort of it. Like it's very sophisticated, like psychological manipulation and social engineering, but anyone can do it. It's not actually a massively innovative thing. This is what you should be doing. You can spend months talking to someone over email before you actually send them the malicious document. Then they have to have like network and systems security capabilities and skills. So once they gain access to the network, they need to scan, they need to look around, they need to find out where they have to go to get the information that they need and to get passwords or dump databases, find the POTS network, all this stuff like that. They have to do that. They have to maintain the malware that they've installed, so they need to update it. They need to make sure that it's running sufficiently. And then when they do their collection, that's when they do all their looting, and they have to exfiltrate that data. So basically, the operator, pretty much all they need to do, find someone, exploit that person, exploit access to that network, maintain access to that network, and pull data out of that network, right? It's very hands-on, low-level technical stuff, but it is not interesting because anyone could do it. That's why they were able to just hire people off the street, essentially. People who are dumb enough to fall for a fake security company with misspellings and very garbled, broken English, and then on the website, and then they would have to speak on a hipmunk with a whole bunch of guys who pretty obviously are not a professional pen testing company. And then these guys would be doing operations which in no way look like penetration tests. There's no penetration test that lasts for 6 months and involves maintaining the illusion of being someone else and carrying on an email conversation until finally, at some point, you send a stealth piece of malware via document macros, and then use that to surreptitiously gain access, and you never write up anything about it. Like that very obviously does not happen in the commercial world. So either these guys are dumb as bricks, or they knew what was going on and they were fine with it, which is my guess. So other than the operators, there's two additional roles that existed, which was the developers and the interpreters. The developers were responsible for maintaining the offensive technology stack. So that's the C2 servers, the like phishing stuff, and updating and upgrading the malware as it went along. If I guess like if there's new business objectives that come out and they take priority and they get tasked with it, then they would have to create new features and functionality to support those business objectives. But as far as I know, like Fin7 basically stuck to what it knew. It wasn't really doing new crazy stuff. And then the interpreters basically just provide operational support to the operators. So they do spotting, assessment, and recruitment support. So they find people who work at the target. They figure out if they're going to be good to go after, like what their level of access is and such. Then they help, for example, with crafting the text of the phishing emails, or I suppose they would do the phone calls and stuff like that. But they just provide support at that end. And then this allows the operators to do asset exploitation. And they will also probably provide support at the reconnaissance phase, because once you get into a network and everything is in foreign, it's helpful to have someone who knows that like slang for backup is this word. So let's look at that. And of course, like while these roles are segregated, the people that fill the role might have multiple hats. So, like one of the managers in support could be a developer, or they could be an interpreter, or they could be an operator as well, right? Like these, like they're clearly not strict jobs in terms of who fills them. They are strict jobs in terms of the responsibilities that they have. Which brings me to my next point, which is by 2025, there's a prediction that there'll be a shortage of 20,000 cyber criminals. It's hard to get the help. So that's from Cybercrime Business Weekly, probably. So those are the people. They've got these roles. They've got people that fill them. They hire when they need to. What is the process? Because this is the core of their business. The process is excellence in criming. So they have a process that's adaptable. It's basically a template that they can use to take any company, run it through their process, and get cash money at the other end. That's the goal. Like you take in pretty much any target within one of your existing verticals, and you process it using the same steps that you use for everything, with the same toolkit, and generally the same process, like the same methodology. And you get the same output, which you can feed into your monetization pipeline, and you get cash. You probably want to have a lucrative monetization pipeline. So you want to go for something with high return on investment. You also want to have a large, dense victim pool that you can exploit. And this typically is going to show up in verticals such as restaurants or stores. Like if you're going after point of sale systems, you need to go after verticals that have point of sale infrastructure and customers that you can steal from. And generally speaking, once you have a process and you've got a target vertical, strip mining the entire vertical is very, very profitable. Like you don't have to come up with a new innovative strategy and a new set of tactics to go after different targets. You just repeat what you're doing on more targets, and that will make you boatloads of money. So that's sort of like the excellence in criming goal. Next, this is the cybercrime process that Fin7 uses, which pretty much everyone else uses as well. Right? It's not, this process is not exceptional. So there's 2 or 3 phases. I've broken it down into 2 because I only know how to make a slide that's got 2 sets of bullet points. If I knew how to do 3, then I would show you 3 phases. So essentially, you've got your like pre and post phase, your pre-penetration and post-penetration. So you've got your access, where you do your target selection, you find out who you're going to recruit, you get them via email, and you make them install the malware. Once you have installed malware, boom, you're now into the exploitation phase, right? You already have access, you're inside, you own that company. Now what you need to do is exploit it. You need to turn that company into cash money. So the access phase is the first part of the process, gaining access to a company. And because they use phishing rather than ODay or straightforward exploits and stuff like that, they can target almost any company because they don't need the company to have special technology. They just need the company to have people. So, they've got this generic access phase that gains them access. Then they have a generic exploitation phase where they explore the network, they find out what's there, and then they establish this sort of continuous exfiltration. So if they can find business accounts or other bank data, they'll do wire transfers. And if they can get access to financial data such as debit cards, credit cards, then they will sell that data. So I have made a very, very awesome business process. And you can see this is basically what they do. You start at your target selection, you do all of your stuff with your asset where you find out who to go after, you convince them to do stuff for you, and then you make them do stuff for you. That gets you into the network, you have a look around, then you hit basically the only decision step you have the entire time, which is determining how you're going to be exploiting them. So either directly via wire transfer or indirectly via exfiltration of financial data. If you're doing it directly, that's a sort of one-step win process. If you are collecting and selling data, that's got 2 more steps. And then you get the money. So this is where it all pays off. The whole point of this whole thing is you put in anyone at the beginning and you get cash money at the end. And as you might know, you can actually you can patent a business process. And kind of wondering if you can patent a cybercrime process. Okay, so I've got a lot of slides. I'm running out of time. Basically, they just use this very, very reliable, straightforward, functional TTP. It's not flashy, it's not exciting, it's not cool, but it works, and it works everywhere. And that's all that you want. Right? You just want social engineering over email, gets you in anywhere. You want a malicious document with an attachment that executes, it'll run on anything. Persistence, you've got generic, reliable malware, installs on anything. And then when you get to exploiting it, you just sniff data, you use POTS implants, or you look around the network for information that's lying around. It's very straightforward, reliable, solid stuff, and it's not exciting, but that's the point. Okay, so they've got people who are in clearly defined roles. The people that they have are a core management team, some early hires, and then a bunch of late hires that just do paid work, salaried work. They have a process which is very, very boring. Spear phishing, install some fucking malware, recon, wire from bank accounts, and steal credit cards. Dollars dishwater. But they made it work. And they made it interesting by doing project management. So because they've got this repeatable process that they can use over and over again, they could have every target be exploited the exact same way, and they could treat every target as a project because it's going through the same process. It's it's simply in progress through the execution of that process. It's not actually special or unique. It's just one of many. And that means that their revenue, like their income, is coupled to the number of active processes that are running at any time. So the more they have, the more money that they're bringing in, which means if they want more money, they need to have more concurrent processes. So in order to maximize their revenue, they need to have more capacity. And that capacity has to enable them to do parallel execution. So they need software that allows them to do this. Bring that up in a minute. So this is going to get us into portfolio management, because what they ended up doing is portfolio management. So this is where you have a number of projects and things that you're doing. And you basically, like you prioritize and control them in line with your business strategic objectives, which in this case is make money, and your capacity to deliver. So if you're going after someone and it's not paying off, then you deprioritize them. And the goal is to balance the implementation of change initiatives and the maintenance of business as usual, while optimizing return on investment. So you want to improve and optimize, make things better. You want to keep making all the money that you are, and you want to make more money over time. And all of that portfolio management is handled by Jira. Fin7 use Jira for their cybercrime portfolio solution. So your problem is that executing a large number of cybercrime processes in parallel is hard. Right? You've got like hundreds of victims. They have different people that you're going after at each one. You have a number of different people working on a different subset and a different combination of victims at any time. You need to track the information and what you're getting back from specific targets. Like you need to do management, and you need to manage your projects, and that becomes portfolio management. So what these guys did is they used Jira for their portfolio management and Hipmunk for their collaboration solution. So this is how they were able to run an effective cybercrime business using existing business technology. So onto their business. Their business is crime. Fin7 was basically Uber for cybercrime. So they found a way to make money. They got their process, and then they just made it big. So once they got product market fit, they scaled. I don't think they had hockey stick take up, but that's what they were looking for. So they got a functioning process, and then they added scale. And they're able to do that because they were able to do portfolio management using Jira and Hipmunk to do collaboration and project management. So because they're a business, I thought that it would be appropriate to create a mission statement. So our mission is to proactively leverage existing long-term high-impact growth strategies so that we may endeavor to deliver the kind of results on the bottom line that our investors expect and deserve. That is exactly what Fin7 did. So they actualized their vision. How did they actualize their vision? Glad that you asked. The answer is crime ops. They basically had a number of pillars that were like load-bearing for their business, and those were a repeatable business process, the bosses spent their time managing workers, projects, data, and money, not actually doing any frontline stuff. They don't need to deal with technical innovation, so they're not actually tied to any external controls in that sense. Like they're not held up by things that advance outside of their R&D on their own part. None of that actually matters because what they're doing is spear phishing and malware. And then because they're not doing technical innovation, they can just do incremental iterative improvements on their existing TTP, and they just need to remain effective. So basically, like, you have to be this high plus one. Right? That's all they were going for. It's like, as long as they could keep operating, that's good enough. And then the other thing is, because they don't need to do any technical innovation, the frontline people don't need to do any technical innovation either, because everything's repeatable. That means that your pool of potential workers is much bigger. So this is where they came into the operational art of cybercrime. They were able to take this process, operationalize it, and make fuck tons of money. So how do you do that? Well, they grew their gang. They had their repeatable crime process. Then they migrated to portfolio management. So they were no longer running the process themselves. They were managing projects which involved the process. Every target became a project which would have resources, current status, and information associated with it. So they were able to do a more hands-off and allow delegation to a number of people, which meant that they could scale up by simply building capacity and increasing headcount. And then with their portfolio management for their targets, they were then able to do project managements within that to track resources, to check the project status, and they would coordinate their team knowledge base so that everyone working on the project would have the same baseline understanding. So what does that mean? If you have a working process, then the bottleneck goes from exploiting your target to scaling your process, right? Once you've got that process down, you don't need to spend time on executing it. You just need to spend time on executing as many instances of it as you can, which means you need to do process management, right? Every victim's progress through the process has to be managed and monitored so that you can delegate to other people and they can coordinate, maintain a shared knowledge base. They can do collaboration and information sharing, and you can reap the rewards by exploiting their work after they follow the process, which you can do by building capacity, which means you can have more people executing the process. The more people you have executing the process, the more money you get at the end, because you are able to exploit a larger pool of victims simultaneously. So, once you've got your portfolio management in place, boom, build capacity and crank it up. That's it. That's the operational art. That's all there is to it. It's easy. So what have we learned? Well, Fin7 should get an award for cybercrime excellence for innovation and achievements in the operational art of cybercrime. They were able to take management processes and apply them to their unique business, which allowed them to scale up with people that were brought in, and that allowed them to execute their process in parallel over a large number of victims, and that allowed them to make a lot of money. And sort of here are the key takeaways. So when you go back and you need to report to your boss how to make your cybercrime group better, these are the things that you want to be talking about. You basically want to move from technological innovation into business innovation, because the technology is not really going to give you massive improvements. It's going to give you incremental improvements. But if you can streamline your business, and if you can make your business more effective, that's going to have a huge impact on your revenue. The important thing is to have a process, because you want to be able to go after a lot of people using the exact same techniques. You want to have this flexible, straightforward process that doesn't need a lot of work. You can just feed something in and money comes out at the other end. Then you will have portfolio management. You want to be able to manage all of your stuff and all of the projects that are going on. Again, project management. You want to be able to track what's happening when you have a large number of people working on things, which you will have because you can do capacity building. And you can do capacity building if you have clear roles and structured teams so that it's understood what people need to do and who needs to do it, who's working on what, which projects they're on, what the current status is. And again, you can make that faster by using DevOps, which will allow them to directly manage their own stuff rather than having someone else coming in and doing support. And if you use agile processes, you can do rapid iterations and maintain your technical effectiveness, but you don't have to invest heavily in R&D to have new technical innovations. But despite all of this, the number one takeaway, crime pays when you move up the value chain into project management. Questions? Yeah.
I like the Cybercrime Excellence Award is a good idea. Actually, it's better than Pony Awards. You know, if you think about it, it's like I think we should just do it. Like find a way to like send it to all the groups. You know, that you get like some random like pictures on social media with the award. You know, the proof of receiver.
I think instead of a reward, they just got a lot of money. So they're probably doing okay. But yeah.
Yeah, it would definitely not be definitely not for the money, but just for like you know, as a concept, you know, like for groups.
Yeah.
Yeah. So first question, actually, like, so do we know who is behind Fin7?
Yes. Yeah. You can Google it. Like basically, there are like 3 or 4 leaders.
So it's Russia, basically.
Yes, they're Russians or Ukrainians or English people that call themselves like Dmitry Popov. Yeah, it's
and your smileys with only one parenthesis.
Yeah, right next to the final letter. Yeah.
Okay.
Yeah, no, like basically, you can read the affidavits, you can read the stuff from Kaspersky. One of the things you'll find if you do start looking into Fin7 is because they're also they use like Carbonac, the malware that at one point was huge and everywhere. You're going to find that there's not actually one Fin7. What there are is a number of people who sort of like come together and split up and do different things, but who all use basically the same TTP, like the same tooling, the same methodologies, the same exploitation strategies, the same monetization. And it's sort of quite hard for external researchers to say, all right, like this is subgroup A rather than subgroup B. So they got lumped together, but you'll see that there's a lot of like different threat intelligence companies will say this set of intrusions was not actually Fin7. It was another group that was using Fin7, TTP. But who really knows?
I mean, there's the thing with attribution. Once the TTPs and the AOCs are out, it's quite easy to make it look like you are another group. And since people are like quite excited about attribution, you know, they're gonna like point the finger to the first group. We think this is those guys.
Yeah. Well, like here's the thing: is you've got a shared piece of malware you've got a bunch of people who've been using it for years, and they all use spear phishing and a Word document. How do you tell one from the other? They're using the same software and the same technique. So and it's likely that some of them used to work with other guys, and they learned how to do it from them. So they're using literally the exact same stuff, just they're not actually that same group. So like FIN7, for the definition of this, is the FIN7 from the FBI's affidavits, because that's where the information on their operational art came from.
Yeah, and if it's actually it's a good. You write a malware, you open source it, a bunch of people use it. Say, oh, sorry. And another question in the chat from Margot. She's asking, are they targeting like only big companies or SMEs or both?
No.
And if they're still active?
They are supposedly still active, but their like executive suite has been cleaned out. I think there's one guy still at large, but of the 4, 3 of them are in jail in the US. So apparently they're still running, and as we were saying earlier, like the people who have the software know how to do this. There's a lot of them. So even if FIN7 itself is no longer operational, then a clone or a variant is definitely still operational. I forgot the question.
If they are targeting only SMEs or multinationals or both.
Right. So basically what they do is they target verticals rather than companies based on size. So from the affidavits, what was listed was stuff from their 2016 to 17 time period. And at that point, they were going after retail stores and restaurants, basically locations which would have point of sale, like POTS devices that would get credit card data and would send it over the network internally, and or could be compromised and would be able to collect like that. So they were going after people who had like a lot of customers coming in. So like restaurants and like shoe stores or anything at a mall. Basically, they just wanted retail stores that had customers that they could steal from. So they weren't, in this case, going after large companies. But sort of the way to think about it is they weren't necessarily going after those small companies either. They were going after the customers of those companies, and they just needed a large number of customers to come in. So what they were trying to do was find places that would have a high aggregation of valuable financial data. And that would be places that had large numbers of customer throughput. And so, retail stores and restaurants are basically bars, things like that. That's what you look for, somewhere where there's lots of people coming through throughout the day. Like you wouldn't want to go after, say, like a car dealership, because like there's going to be one purchase or like 3 purchases in a day. Right? It's not going to be very useful. So they weren't going after big people. They wanted large numbers of customers, so smaller, at least for this set of campaigns. They are credited with doing a large number of stuff, including banks, ATMs, like large enterprises. But the attribution is very iffy. I wouldn't trust it completely.
And on the money laundering part, because that's something you didn't cover, do they have like a specific modus operandi, or like what do they usually use? Like
so like they've got money mules, which are basically like they're a service that you can contract from the Russian underground. It's people who have money wired into their account. They keep a percentage and then they send the rest via, say, Western Union or some other method. They send the cash onwards. So They could do that to cash out. And then in terms of the credit card stuff, they were just selling the credit card and debit card data to other criminals, and they would take that cash. So they didn't actually need to do money laundering in the sense that the money that they had was clean, like it had already been processed by the time they got it. It was illegal, like, but they're in Russia. So, like they're not really going to get done by like the IRS for failure to pay taxes or anything. Like that's not a problem that they had to deal with. They were getting money in via cash, wire transfers, probably web money, whatever they were getting from other criminals, crypto stuff as well. Like anything that they needed to get cash in, and then they could just disperse cash as salary internally with wire transfers to a bank, and it doesn't need to be processed additionally, because by the time they get it, it's cash money, right? Like, so.
Although for like BEC campaigns, I'm sure you saw like a few weeks ago, like was it the FBI or like whatever, the Department of Justice, when they announced like the 6 people from Nigeria that were on the watch list. And at the same time, like a week later or so, like there is a hush puppy who's like quite a well-known Instagrammer who got arrested in Dubai. Like Dubai police released a pretty fancy video about his arrest. So I mean, very likely it's probably like related from the same ring, like you don't see like 6+1 like Nigerians being arrested for like BEC scams, like in 1 month, without any relationship. But I guess like same thing with them, like the money laundering part is quite interesting. I've been trying to get in touch with some of the people doing those operations, just to have like some anonymous interview or whatever. I think that would be quite fun. But they never reply to my emails.
Dear sir or madam, I'm a Nigerian prince. Hello, please, yes. Can I ask you how you fucking launder money from the people who fall for your scam?
They're really good. I investigated a bunch of like BC like scam from Nigeria. Like, they reply to the emails, or like they are like they're quite professional. They would be good good PAs, like not just for the emails. I know there is a bunch of companies that receive some money for.
Well, now everything's remote. They could actually open up a call center.
Yeah, like
virtual PA.
like those call centers in India, like those support scam stuff, that the guy keeps like chasing and then he's looking at the CCTVs. That would be quite a fun thing to
awesome.
do.
You could get like Nigerian Yahoo boys doing virtual PA stuff.
Yeah, I mean,
imagine if they screw up the email. So yeah. Yes, in relation to the request to rebook your tickets, I want to let you know that you have a unique opportunity to help me move $10 million.
No, but they're pretty good, because actually they do target a lot of like Office 365 stuff and everything. Like, but I don't know if they use malware. So I think they just do like some spear phishing. Like not even like regular phishing. Get some emails going. People don't use like 2FA, and that's it. And they've been doing quite well. But yeah, another question. I think that's the last question is. For this to be a true Uber of cybercrime, someone needs to create an app that requires the fastest compromise, finds the cybercrime team to take the project, and gives 45% to the app makers.
Yes, that's correct. Once they had their process, they needed to make an app so that anyone could sign up and do it.
And then they can start a marketplace.
And then
like everyone can put their own malware. So
the first cybercrime unicorn.
Yeah, exactly. I thought it was called NSO.
Yeah, no, actually, Fin7 are credited with over $1 billion that they've stolen. So technically, they are a unicorn. So you can learn a lot from cybercrime unicorn.
A unicorn means your valuation is $1 billion, not that you generated $1 billion of profit. So technically,
but see, if you take their revenue and then you project it over, their estimated duration,
it would be like the next Amazon if you want $1 billion of revenue,
Twitter has like 2 billion in revenue, so these guys have got to be worth more than that.
Yeah, exactly. Yeah, like what's the F7 ARR? It's a good question actually. Like in terms of numbers, because like those numbers about campaigns are a bit like iffy. It goes in every direction. You don't really know it's computed.
So there's the concrete numbers are 100 victims. That there's someone who had a Jira instance that had 100 active projects. Mm-hmm. However, some people have credited thousands of victims, which I think is that it's attribution expansion. It's bullshit. It's not real. But I think hundreds is accurate. At the same time, I don't think 1 billion in stolen money is accurate, because that's very much like those dodgy numbers, like where the police sees like fucking $3 million worth of marijuana in 2 dime bags. Like it's like I don't trust those numbers from external people. Plus, like they're gonna lose. Like that's not even if they had 1 billion in revenue, their profit is going to be much lower, because they're going to lose a lot to money mules. They're going to have to pay out salaries, so they're going to have to pay for infrastructure. They're probably just going to lose some amount. Like you'll send stuff to money mules and they'll just keep it. Some amount won't be able to get wired out. Will get sent back. All sorts of shit can go wrong. So I'm pretty sure that they did not have 1 billion profit. But 1 billion in revenue over 5 years, and they've got a good business model. They can keep going, I think. So, I think their projected growth would be interesting.
So what did you mean about 2025 and the shortage of cyber criminals? Did you mean like cybercrime is going to go down, or cybercrime is going to go up and they're going to need more resources? Or automation is going to replace them and make them redundant?
I was just joking, because when they have to do capacity building, they have to hire people. And anytime you talk about hiring in cybersecurity, there's always this shit saying, there's going to be a shortage of 1 million cybersecurity professionals by 2025. Gartner are predicting that, by 2025, there will be a shortfall of skilled cybersecurity people of like some stupid, ridiculous number. So I thought, if these guys are a business, they're recruiting from a pool.
Yeah.
At some point, someone's going to start predicting that the pool of cyber criminals is not going to be sufficient for all of the roles in cybercrime. Yeah.
I mean, especially phishing emails are still efficient, definitely, definitely a lot of interesting prospect for that.
Yeah. All right,
Cool. Well, thanks again. Actually, do you have any recommendation of people who could invite to talk about like corruption or money laundering? I think that could be quite an interesting topic to cover as part of the.
If I knew someone who had enough money that they needed to launder it, I probably would be a lot.
No, that was not my question. That's not the question.
I don't know people who do that.
No. My question was like someone who can talk about it as like, like I don't like academics, like some.
Yeah.
Not how to. That's not what I said.
That kind of criminal, I don't run in those circles. My Rolodex does not have a lot of mob bosses, so no, I don't know. But I think I can talk to someone who can maybe get you like money mules. Like I know some people who do a lot of research on Russian underground.
Yeah,
and
that would be cool.
They might be able to they can either talk about it, or they can maybe get you access to interview someone.
Yeah, that would be cool. Could be interesting. Cool. Well, thanks again for joining us again.
And thanks for having me, man.
No worries. Take care.
Cheers. See ya.
Bye. And now we're gonna get ready for our next speakers. We've been waiting patiently for their turn to speak. So the next presentation is going to be Scoop, the Windows 10 pool. So it should be quite interesting from Corentin and Paul from Synactive. Are you guys here? Can you hear me? Yeah. Okay, cool. Okay. Yeah, let me just launch the transition and you can start sharing your screen and everything.
Okay.
The future is watching. Welcome to Opcode Virtual.
Did you share your screen?
Yeah, just now.
Okay. And I think, yeah, we're good. You guys can start. Sorry again for the delay. But thanks again for waiting. Thanks.
Okay, so we can start?
Yeah, you guys can start.
Okay, thanks. So thanks, Matt, for the invitation. So thanks for viewers to come listen to our talk. So we're gonna talk about the Windows 10 pool, which is a heap allocator in the Windows kernel. But first, a little bit of presentation. So I'm Corentin. I'm working at Synactive for about a bit more like 2 years. And I already worked a bit on the Windows kernel heap exploitation. I did a talk about this in a French conference based in Paris. And the work we will present here is the following of this work with the introduction of new features in Windows. And I'm with Paul.
Hi everyone. Thanks. I'm Paul Fariello. I also work at Synactive, and previously I've done some work on VM Escape and exploiting Linux stuff. And as Corentin said, we are both employees at Synactive. It's a offensive security company, which was created in 2012. We are about to be 74 employees at Synactive, and we work on different kind of mission, pen test, reverse engineering, development. And we are spread across 4 cities in France, so Paris, Toulouse, Lyon, and Rennes.
Okay, so we're going to talk about the Windows pool, which is the heap allocator in the Windows kernel. So it exists as such since Windows 7. It's evolved through the release of Windows with mitigations and new features. But recently, in the first release of 2019, the segment heap was introduced in the kernel. So the segment heap is an allocator that exists in Netherland since Windows 10, which is optional. But now it has been backported into the kernel and bring a lot of changes to the pool we knew. So the goal of the research was to discover what changed in the pool, what was the impact on the pool specific pool materials that the kernel needs, and most importantly, what was the impact on an exploitation point of view. So especially if you have a heap overflow, if there is still metadata you can target, and what kind of exploit you can do targeting these materials. So first, we're gonna talk about a bit of the pool. So the internals of the pool, both before and after the introduction of the segment heap. And once we know more about the mechanism in the pool, we're gonna talk about how we can exploit a heap overflow, and we'll present a novel technique we developed during the research, step by step, an exploitation to elevate its privilege from low to system, and a little demo and a conclusion. And I let Paul introduce the Windows pool.
Okay, thanks. So let's dig a bit into the Windows pool. So as Corentin said, the Windows pool is the allocator in the kernel. And this is the API that is exposed by the kernel. So there is mainly 2 functions. The first one to allocate some memory, and the second one to free the allocated memory. One important thing here is that there is three parameters to the allocate function. The first one, the obvious one, is the number of bytes that need to be allocated. And then there is two another parameters, a tag, which is used mainly for debug, and a pool type. And so let's dig a bit into the pool allocator to know what the pool tag is, the pool type is used for. So the tag is, as I said, mainly used for debug. It's a 32-bit value, usually printable, so the developer can debug easily their code. And then there is a pool type. So the clients of the API can request the allocation of memory in different kinds of memory. So there is three main kind of memory: the non-page pool, which is memory that can be paged out by the kernel. And since Windows 8, there is also a non-page pool NX, which is not executable. Then there is a page pool, which is memory that can be obviously paged by the kernel. And then there is session pool, which serve another purpose, and we won't dig into this. And there is another thing that the allocator can do. It can add some features, some specific features. And these features are enabled with bit by selecting bit on the pool type. So mainly we will only see these two features, which are quota and alignment, and Corentin will present it later. So if we want to sum up how the kernel pool works, there is, as I said, the pool type, which chooses which kind of memory that can be used. So the page, non-page NX, and session. Then the pool allocator needs to allocate memory. To do so, it can use what is called a dynamic locuside. Dynamic locuside was here before the introduction of the segment heap, and we will present it later. And if it don't find memory in the dynamic locuside, it can give a try with the segment heap. So the segment heap is a new allocator, which has several components in it. And once it has allocated memory, it can apply some additional feature like alignment or quota. So as the segment heap is a new thing, we will dig a bit into it. It was introduced in user land, so not the kernel, but in user land since Windows 10. And it was optional. So user could decide to use it or not. But since the latest major release of Windows 10, 19H1, it has been backported into kernel, and it's not optional. Every driver that wants to allocate memory will use the segment heap. And the segment heap brings some radical changes, and mainly it aims at providing different features depending on the allocation size. So we will cover how we do that. Inside the segment heap, there is different kind of so-called backends, which will do their own allocation and free mechanism. And the chosen backend depends on the requested size. So the four backends are low fragmentation heap, variable size, segment, and large. And we will cover only the two first here because they are the most commonly found from an exploitation perspective. So to sum up, for really small allocation, there is a low fragmentation heap, so LFH. Then for a bit larger allocation, there is a variable size backend. And for even bigger allocation, there is directly the segment backend. And for even bigger, the large backend. So let's dig a bit into the LFH and VS backend. The goal of this slide is to understand how they work, because from an exploitation perspective, it's important to know how they work, because if you want to message the heap or shape the heap correctly, you have to understand how they do the allocation. And if you have, let's say, a heap overflow, you want to know what the kind of memory are behind your overflow. So let's start with LFH. LFH, as I said, is for really small allocation. The aim is to avoid memory fragmentation. So it's backed by multiple subsegments, so segments that are coming from the other backend. And it allocates a huge segment and then splits it into smaller blocks that will be allocatable by the user. And each subsegment will contain only block of the same size. And there are then multiple subsegments can be grouped into a bucket, and the bucket will reference the size. And so what we can see here is that between two blocks, there is no specific data, no specific metadata or information regarding the block. So every data or metadata is stored in the header of the subsegment. So specifically in a bitmap for free or used blocks. And there is two more things to know from an exploitation perspective. The first one is that there is a feature called affinity slots that can be enabled, and it's enabled in order to avoid contention. So it will assign a given subsegment to a given core. So you might, if you do a lot of allocation and free, you might trigger this feature, and it can be quite a mess then to have a good shape of the heap. And the other thing to know and to have in mind when you are exploiting a heap overflow is that the allocation are kind of random. They won't be, you won't have the same layout each time you do like an allocation. So that's it for the LFH, and now the variable size segment. So it's for bigger allocation. Again, it's backed by subsegments of huge pages that are split into multiple chunks. But this time, the goal of the variable size backend is to avoid loss of memory. So avoid to have empty chunk left over. So to do so, it will maintain a red-black tree in order to know which chunks are free. And it will also try to merge 3 free chunks that are contiguous. So it can be quite a mess when you try to exploit a heap overflow. And finally, what we can see here in the schematic is that between 2 chunks, there is a specific header specific to variable size, which will store the size of the next chunk. And if the chunk is free, it will also store the node of the red-black tree. So here we have seen that there is lots of things that have changed in the segment heap from the old pool, and mainly that we don't need specific information to be stored outside of the backend. And I will let Quentin talk about that.
Yeah, thanks, Paul. So previously in the pool, every chunk that was smaller with a page was preceded by a pool header. So a pool header is a structure that contains various information like the chunk, the size of the previous chunk, the size of the current chunk, or which pool descriptor is used, things like that. And with the new backend, with the new segment heap, all those information are stored directly in the backend. So the question was, is there still a pool header? Because it seems like all the information we need doesn't need to be stored inside the pool header. So yes, there's still a pool header, and so we wanted to know how it was used and if we could use it from an exploitation point of view. So as we saw just before, there is 3 mechanisms that we didn't explain yet in the pool, which are the dynamic leukocyte, the alignment mechanism, and the quota mechanism. And those three mechanisms still use the pool header, and that's why we still need it. So first, the dynamic leukocyte. So the dynamic leukocyte is a mechanism that's here for performance. So it only works for allocations that larger than 512 bytes, so only for allocations that use the VS backend. And the dynamic leukocyte is a dedicated linked list of free chunk. So when a precise size of chunk is a lot used, it's a lot freed, and it's a lot allocated, and the dynamic leukocyte will be enabled. And then instead of using the backend to freeze the chunk or to allocate the chunk, it will directly store the chunk into linked lists of free and allocated chunks. And then it will be way faster, but there is no check. The backends do a lot of check on the chunks to see if the size is coherent or things like that. And that mechanism doesn't do any check. And since this mechanism cannot use the size that is stored into the backend, it has to use the size that is stored in the pool header. So the pool header still has the chunk size field that is filled with the actual size of the chunk. And this is what the dynamic look aside use. So this is interesting for us because if we have a pool overflow, we will likely be able to control the pool header and then to control the size, and maybe we can mess around with this mechanism to do some interesting stuff. And this is what we will do. So that's it for the dynamic look aside. And another mechanism is a pool quota mechanism. So this is a mechanism to monitor the heap usage. So you can a user can enable it with by setting the pool quota bit in the pool type, which is bit 3. Through the e-process structure of the process that did the allocation, stored into the pool header, and when the chunk is free, the counter is decremented. So basically, you have your chunk with the pool header, and the process build pointer is stored there and points into the e-process pointer structure. Sorry, and it's used to retrieve another pointer that points on a counter to decrement or increment it. So this mechanism was an attack exists on this mechanism that was described by Canal Pool in 2011. So he called it the quota process pointer overwrite attack, and it's leveraging heap overflow to overwrite the pool header of the next allocation and control the process build pointer to make point to a fake heap process, and like that we can get an arbitrary decrement primitive, which can be enough to elevate your privilege to system on Windows. So this looks like that. You have a two chunk, another chunk before the another chunk. With the overflow, you will override the pool header and then control this pointer. Then you can control this pointer and control the counter that is decremented, what is decremented. So that was available on Windows 7, and then it was mitigated in Windows 8. So now the process build pointer is XORed with the randomly generated cookie. So instead of just having the address of the e-process structure, the pointer is now XORed with the address of the chunk and the value of the pool quota cookie. So you can't forge it without a strong leak or a straight read primitive, and if and there's a check obviously, and if the check fails, then the kernel crashes. So this is basically what I presented at the NUDUAC 15 a French conference. So you want more information like that, you can see it if you speak French. And that's it for the quota mechanism. And finally, there is the alignment mechanism. So this is a mechanism that allow the users that allocate the memory to request that the chunk is aligned on the CPU cache line. So you just have to set the cache line bit in the pool type, which is a bit 2. And to do that, the allocator will simply allocate a bit more memory, and will use the extra memory to align the pointer. But the thing is that the chunk must respect 2 conditions. They have to be a pool header at the very start of the chunk, because there is always a pool header at the very start of the chunk, and it must have a pool header just before the pointer returns to the user, because it's a pool header that can be passed. So in a normal usage, you have one pool header is enough to respect these 2 conditions. But if you align the pointer return to the user, you might have need 2 pool headers to respect these conditions. So you might have a layout that looks like this, where this is the chunk allocated, that's here. This is the pointer returned to the memory, and usually you will just have one pool header just behind, but because of the memory, there was a gap between the start of the allocation and the pointer returned to the user. So what does that mean? That there's a second pool header here, and there's a first pool header here, and the second pool header has a previous size field, which is the offset to the start of the aligned string. So it uses this value to retrieve the first pool header and then use this pool header to do the free mechanism. So this is a mechanism we might use to exploit an heap overflow too, and we'll see that later. But first, I will let Paul conclude on this part.
Okay, thanks. So as Corentin said, we have seen that the memory that is returned to the user can be shaped with various headers. And the headers that are chosen depends on the backend used by the allocator and the feature enabled in the pool type passed to the API. So if we want to sum up, here is a decision graph that the kernel will follow in order to know if it has to add some specific header. So for small allocation, it will use the LFH, so it won't have specific header for that. But you can see for bigger allocation, it will have the VS allocator and backend, and it will use a specific header in front of each chunk. And after that, once the allocation is done, it will go through the end of the chart. And if the allocation size is smaller than a page, it will try to add a pool header. And if the user requested the cache alignment, then it might add two pool header in front of the chunk. So we have seen that when you have a heap overflow, you might have some interesting data to overflow, but it depends on where you are and what you are overflowing. So now the question is, how can we exploit a heap overflow from this kind of inner working of the pool allocator and from this kind of memory layout? So it was the main question we had when we started this research, and the main takeout is that if you have a big overflow with controlled data, it's probably better to do a full data attack because you can overwrite the pool header that is present in front of the chunk. Sorry, my child are regressing me. And if you can overflow the pool header, you have to be careful that the pool header don't crash after that. So to do so, you can ensure that the pool quota bit is not set in the pool type. And after that, you can overflow the data that is after the pool header. And you have to be careful because if you are overwriting a chunk that is present in the variable size backend, then you will have to overwrite the VS header, and you can't fix it right away because you have to first have a leak of data in order to fix the header. So you have to be really careful with that. And the end of the research for Corentin and I was to try to exploit an overflow which was of only 4 bytes on the pool header. So to do so, we developed a new technique called aligned chunk confusion. And before Corentin present you a step-by-step explanation of the exploitation technique, I will just do a quick recall of how the free mechanism work for the aligned chunk. So when freeing an aligned chunk, the allocator needs to find the real address of the start of the chunk. And to do so, it can simply look at the pool header that is at the second pool header and find the previous size field of this pool header and then just compute the original header. After that, it has the original header pointer, and it can just do its normal work with it. And this is this mechanism exists since the introduction of the pool allocator. So it was here before the introduction of the segment heap. And there were multiple checks done when it was freed. So I won't go into details with the 3 checks, but they were here, and I can show you the compilation code of the free. So here you have first line is the check that will just ensure that we are working with a chunk that has the cache aligned bit set in the pool type. And then there is 3 if with following by KI bug check that will ensure that the 2 pool headers are correctly aligned. And this was the code before the introduction of the segment heap in the pool. And since the introduction of the segment heap, we have seen that all checks are gone. So it's quite interesting from an exploitation perspective because the less checks there are, the more room there is for us to do the exploitation. So we developed a technique called aligned chunk confusion. And here is a quick overview of the technique. So let's say you have a vulnerable chunk where you can control a heap overflow. So the red one, the bottom of the schematic, and you can overflow the 4 first bytes of the pool header following, so the pool header that are part of the overwritten chunk, the green one. If you can overflow these 4 bytes, you can change the pool type, so you can set the cache align bit in the pool type. And you can also set a previous size that will make the pool allocator think you have a pool header inside the vulnerable chunk. And then we can leverage the dynamic local side to reuse the created chunk, which we call ghost chunk. And in order to better understand this technique, I'll let Corentin present a step-by-step explanation.
Thank with this technique. So first, the goal of the exploit was to demonstrate the exploitation technique and not to demonstrate a vulnerability. So we just created a fake vulnerability with a driver, with a vulnerable driver we wrote. And then we started the exploit. So the goal of the exploit is to leverage the align chunk confusion to elevate our privilege from a low integrity to system. And the goal was also to develop a generic exploitation technique so that can work in both page pool or non-page pool NX, which are the 2 main pool types used by the kernel. And an exploit that is independent of the size of the vulnerable chunk, because usually when you will exploit a vulnerability in the heap, the exploit will be very different depending on the size of the vulnerable chunk, because you will use different backends or things like that. So the goal was to be independent of the size of the vulnerable chunk. And to do that, we just require a vulnerability that provides us a few primitives, and the primitives are just the ability to overflow and control the first and the fourth bytes of the following pool header, and the ability to control the allocation and the free of the vulnerable chunk, which is something you usually have when you do an exploit. And this is because we need to spread the memory to message it a bit, and we need to control the allocation free of the chunk. So the strategy is something like that. We are going to use the align chunk confusion and the dynamic side to create a chunk that doesn't exist, a chunk that shouldn't exist, and that only exists in the dynamic leukocyte, so in the pool mechanism, and we call it the ghost chunk. And then the goal is to allocate an object in the ghost chunk. And because of this particular layout where the several chunks are overlapping, then we will be able to obtain read and write primitives by overwriting the object in the ghost chunk. And yeah, and then the first goal is to find an object that is interesting to put in the ghost chunk and to override then. Yeah, so the object needs to have different properties. The first property is that it has to be sprayable, which means we can control its allocation and its free, and we can do it massively, so we can spread the memory with it. Then the object needs to provide some kind of primitive, like an arbitrary read or an arbitrary write, if we control it with user data when we overwrite it. And finally, the object has to have a variable size, so it can be generic to any overflow, like we just said before. It should adapt to any size of an enable chunk. And because we want it to work both in page pool and non-page pool NX, we need one of these objects in the page pool and one of this object, in the non-page pool NX. So here we'll present the object in the page pool. The object on the non-page pool NX is in the paper of the research. We will link at the end of the talk. But I will just talk about the page pool, but the non-page pool NX is very similar. It's just another object. So the object we use for the page pool is the pipe attribute. So it's an object that is linked to a pipe. After the creation of a pipe on Windows, you can set attributes to it. So an attribute is just a name and a value, so a key value pair. And as you can see, the object has different fields, like a list of all the attributes linked to the pipe, the pointer to the name, size of the value, and the pointer to the value. And all the data, the name and the value, are stored directly in the object. Which means because we control the name and because we control the value, we can grow the object as we want, and he has a controlled size. The other interesting thing with these objects is since we fully control the name and we fully control the value, it's a great way to put arbitrary data in the kernel, in the heap kernel, and use it for example, overwriting the ghost object. And finally, once you created an attribute, you can request to read the value of the attribute just by giving the name, and then it will walk through the list and with the name match an attribute, and then use the pointer here to retrieve the value and return it to the user. Which means if you control this pointer, then and you request the read of the attribute, then you have an arbitrary read. And this is exactly what we are looking for. So now the strategy is to use the align check confusion to override the next pointer and create a ghost chunk. And then we will put a pipe attribute into the ghost chunk to get first a leak, and then overwrite it to get an arbitrary read. And an arbitrary read is not enough, of course, to elevate our privilege, but we also have a pool overflow, a heap overflow situation. So using the arbitrary read, we can read different secrets in the kernel and then use the Kocha process pointer override attack we presented before to elevate our privileges. So we present it step by step. First, there is the shaping. So we just need a layout like this, the vulnerable chunk followed by any object that we control. We just need to control when the object is freed, nothing else. So this is not quite hard to have with a bit of spraying. So we can trigger the vulnerability. Then we will, with that, we will overwrite the first byte of the pool leader. We'll set the cache align bit in the pool type, and we'll set the preview size with the value that points back in the vulnerable chunk. After that, we can free the vulnerable chunk and replace it with a pipe attribute. So why a pipe attribute? Because from here, we fully control the data, so we control the name and the value. So we can craft any data here, and we are crafting a fake pool leader. So it will be used just later. So now we can trigger the free of this chunk. And because of the align chunk confusion, instead of really freeing this chunk, it will go back to find another pool leader, which is crafted there. And because we enabled the dynamic leukocyte list, instead of using the backend, it was use the dynamic leukocyte list and create this chunk that doesn't exist and just put it in the dynamic leukocyte list. And the backend doesn't know that this chunk exists. And now we have a ghost chunk that is overlapping with the two other chunks here. And now we can allocate a pipe attribute in the ghost chunk. And because the two chunks overlap, this will just overwrite all the data. And as I said before, you can read the value of the attribute. So just by reading the value of the yellow pipe attribute, we can get a leak here. We can get the leak of we can read the value of the pointer and the value of the pipe attribute. And since there is a pointer to the name and the value, we get a pointer. We get a leak of a leak heap. So we get the leak. We got the address kernel of all this setup. So this is great, but now we want the arbitrary read. So to do that, we will free again the yellow pipe attribute and reallocate it. So this time it will override the ghost pipe attribute with our data we fully control. And when we do this, we will just inject a new pipe attribute in the list. And the pipe attribute will point in userland. So because on Windows, there is still no SMAP, so you can totally use userland data in kernel code. There's no SMAP to support for retrocompatibility reasons. So we can inject a pipe attribute in userland, and then each time we will request a read and the attribute value of this pipe, it will walk to the list, come to our fully controlled pipe attribute, and we can point the arbitrary value to an arbitrary location and just have an arbitrary read. So now we have an arbitrary read. We got a leak, so we can walk through the kernel memory and retrieve some values. So we want the value of the cookie that was randomly generated. We want the address of our e-process and the address of our token we will use later. And then we can use the attack we presented earlier, the quota process pointer attack, to get an arbitrary decrement. So how do we do this? We once again free the yellow pipe attribute and reallocate it with another one. This time we're not targeting the pipe attribute, but we're targeting the pool header. And we'll just set the pool quota bit to 1, and we'll override the process bill pointer to make it point to controlled e-process. And once it's done, when we will free the ghost chunk, it will use this pointer to find another pointer and use the decrementation. And since we control everything, we can get an arbitrary decrement. So how do we use the arbitrary decrement? Every process on a Windows system has a token, and this token is stored in kernel memory. And in this token, you have two bit fields called privilege.enabled and privilege.present. Those bit fields just contains which privileges your process have, and basically by default, this bit field will have a value like 8000000, and if you just decrement of 1, it becomes 7FFFFFFF, which is a lot of privileges. So a few releases back, you could just decrement the enabled bit field, and it was enough. But now both bit fields are checked, so you need to decrement present also. And once both bit fields are decremented, we get the cdebug privilege for a process, and this privilege just allows to debug any process on the system. So we can debug a system process and inject a shellcode, and that's how to get root. So we got a little demo here. It will go quick. I hope you see it. Okay, so we have a terminal here. It's running with a normal user, only low privileges, as you can see in Process Hacker. It's not the latest version of Windows. This is a second release of 2019. So the exploit takes two arguments: the size of the chunk we are targeting and the pool type we are targeting. So here we're targeting a chunk of size 0x150 and the non-page pool NX type. So, and very quickly, we get a root shell, system shell, sorry. So you can see it's running under winlogon.exe, which is a system process we debugged, and we get a system shell. And that's it for me, and we'll let Paul conclude on this talk.
Okay, thanks. So a few words about this exploit. So first thing is that, as you have noticed, we could have used the same exploitation technique to achieve different outcomes, something like code execution in kernel or stuff like that. But we choose to reuse a known technique to just gain privilege escalation. Another thing to know is that the exploit is not perfectly stable because of spraying. It could be improved, but it was just a bug. We only tested it on one version on Windows 10, and there is some offsets that are hard-coded in the exploit, but it could be fixed easily by using the arbitrary rate that we have early in the exploitation. Anyway, everything we have done is in the GitHub, in our GitHub, thanks. And we have the fake driver exposing a fake vulnerability to test the exploitation technique. We have the proof of concept code, and we have a full paper with lots of details on how the exploitation works and how the segment heap works. So that's it, and a few words of conclusions. We have seen in this presentation that the segment heap brings lots of changes in the pool, but it mainly removed some mitigation that have been here for a long time, and it allowed us to develop a new technique. And our exploitation technique works with any heap overflow providing two things: controlled allocation and deallocation of vulnerable chunk, and the overwrite of the first and fourth bytes of the pool header. And if you have any vulnerability that provides these two primitives, then you can use the technique we developed in the page pool, in the non-page pool NX, for any vulnerable size from 0x 30, if my memory is good, to a page at most. So that's it for us. And if you have any question, we'll be glad to answer it. Thanks.
Thanks for your presentation, guys. It was very interesting. There's one question in the chat, which is, are we bypassing SMEP? So it's quite an old question. So I don't know if it was answered after.
Since we never execute code in kernel, actually, because we just enable some privileges for a process.
Yeah, the token one, right?
Yeah, the token.
Yeah.
So we don't need to execute any code in the kernel, or in the user. So yes, we're bypassing it, but we didn't try to bypass it because it wasn't necessary.
Makes sense. And can you go back on the link where there's like the GitHub resources, just for the people?
I might give it in the chat if you want. Whoop. Sorry.
Oh, cool. Because anyway, you know, like on the GitHub of OPCODE, I will send you the link after, but you can do a pull request, or just send me the link in a DM, and I can add it to like the README for today's edition. So if there is like slides or anything, we can just put everything there. Cool. Well, I don't think there is more questions in the chat. So yeah, I think that's it question-wise. So what's on the GitHub? What can people find on the GitHub?
There is the code of the exploit, of the POC exploit. There is a link to the paper, which is in English. And if you go on the stick page, so where there is the paper, there are also the slides. And yeah, that's it.
What are the slides for stick, in French or in English?
It's in English, it's the same slide.
Oh, okay, cool. Okay, awesome. You're saying, Paul?
Yeah, if you have the code, you can replay the demo we played, and you can play with the size and the kind of memory you want to try the exploit.
Awesome, cool. Well, thanks again, guys, for joining us and for speaking at OPCODE. Really appreciate it. You would definitely make the resource available on the GitHub, and we're probably gonna cut the presentation tomorrow, so we have like different segments instead of having one big block with all the talks. But yeah, thanks again for joining us. Take care, guys. Bye.
Bye.
And we are back for a new transition. So for that transition now, what we will do is I will get ready for the next presentation. And since the next speaker is basically me, I have to remember like the things that I wanted to show. So yeah, I hope you're enjoying OPCODE so far. So if you have any questions, you know, like definitely don't hesitate to like type in the chat or come join the channel on Discord. Usually some of our speakers are still there. If you have like questions that you forgot about, all the videos are going to be available on YouTube, and the resource materials or the link, you know, like will be on the GitHub I mentioned here at this address. So yeah, don't forget to subscribe so you get notification and you don't get you don't get flagged in the spam. Actually, I just I retweeted it on Twitter. I'm not gonna show it on YouTube, but that was it was quite funny. I was in the middle of a bunch of like spam emails for in a friend mailbox. That was quite entertaining. So yeah, for our next presentation, we're gonna be talking about Windows ARM64 exploitation. So I'm just gonna get ready on my side, and yeah, I will explain to you right after.
The future is watching. Welcome to OPCODE Virtual Summit.
Cool. So yeah, we're back. So I was saying, so we're gonna be talking about Windows ARM64 exploitation. So basically, I've had an ARM64 Windows laptop for around a year now, I guess. And was it 1 year? Something like that. Yeah. Let's say a year. And initially, I just like used it for like one afternoon to dump it to work on ARM64. And that's it, I never really touched it anymore. Although it's quite a nice machine, like it's very light, like the battery lasts like for a very long time, like more than 10 hours. So overall, it's quite a good laptop, but I didn't really use it to do like more security research. Also, like if you try to use Visual Studio on it, like it's like pretty slow. But yeah, other than that, it works quite well. There's some applications, like WireGuard, that were not ported to ARM64 yet. But otherwise, most of the stuff work fine. There's 32-bit emulation, all those things. So yeah, I didn't really do more research on it until I saw the exploit that Chumpy released for SMB Ghost. I was like, oh, that's quite cool, actually, like a good opportunity to look more into details of or like remote exploitation works now on Windows 10, especially like with all those like security mitigations happening. I didn't write any exploit in a long time. And I was aware that could be a good opportunity to also learn ARM, So I worked on that over the past 2 weeks, I guess. Even like in the last OPCODE, I mentioned it. I was like, oh, like I got stuck on something. So, which was like ARM64 related for a project. So that was for that one. And one of the things, start zoom here. Yeah, one of the things which is quite interesting with this is like a lot of things are like very similar and a lot of things are like completely different. So that's pretty cool. So as you can see, I'm doing all the checkbox of having an exploit. So I found the name, which is like the name of my dog, and I called it SMB Balu. So it's nice, and instead of having like a scary name and scary thing, I was like, well, what about just making it like something like more calm and more peaceful and something nice and friendly to look at, instead of like finding those names like Corona Blue or like those like scary names that no one really care about, and then people keep reusing everywhere. So for this, so unlike Grok, I didn't prepare any slides, but that blog post is just available now. There is the exploit on GitHub, which is available. So I'm just gonna like try just gonna do it in a Twitch format where I'm just gonna like take my blog post and break it down and use it as a support for my presentation today. So first of all, because and also that's something I've been complaining a lot every time when I like when I get people like speak, or when we are in the review board of I'm on the review board of a few conferences, is people not giving acknowledgement of references to like people who have been doing like research on a past subject, because usually it's always built on top of a lot of like other people research, and I think it's normal that we can acknowledge and credit them, especially if you're like new and you want to learn. It's always good to have like reference link that you can go to read, so it completes like whatever you want to learn about. So regarding SMB Ghost, hats off to Huge Og for his great blog post about the vulnerability, and as far as I know, is like the first blog post I've seen on it. He was explaining how to do physical memory read from the vulnerability, but also the vulnerability itself, which was quite nice. And Chumpy for POC exploit, which is pretty good. My ARM64 exploit is like heavily based on it, so all the SMB features are just like based on the exploit, and whatever is different is just like whatever would change with the exploitation. So for instance, to find we will see it, but like there is no PLM4, and I don't even use that at the end of the day because that will not work anyway. Like the ACPI table does not exist anymore, so all those things like are completely different from the exploitation point of view. But for like the compression and the SMB like functions, that's completely like based on the exploit, and it's pretty well done. Also found a bug in it because I was not able to read like physical memory like reliably, so that was improved too. Zekops and Michael Maltsev, they did some pretty good write-up on the actual vulnerability, so that was quite nice too. Some good blog post. I also want to give like a special thanks to Stephen Ridley because for being like so Stephen has been doing a lot of research on ARM, published a lot of like papers and gave a lot of trainings on it. Also I've known him for a long time, so he's a good and supportive friend. And but at the time when I wanted to get an ARM64 laptop, especially last year, it was very hard to get one, and Steven is the one who basically got one for me and shipped it to me, because it's like impossible to find in the Middle East. Even at some point I was like in Singapore, I tried to find it in Singapore. I think it was only available in the US at that time. Now it's a bit easier to get an ARM64 laptop. Unfortunately, and I try to find numbers, if any of you, like in the chat or watching this, like I can't find any numbers about like ARM64 laptops or machines, being used on Windows. I would be very interested to know about how many devices are in circulation now, because impossible to find anywhere. And with the Surface Pro X now, I would assume that number is going up. Also another reason, like why doing that research was also like an interesting thing due to the timing. And so for that, obviously, like to Barnaby, I was talking about it with Zero Sum. As far as we can read, is like the first person who publicly talked about APC injection techniques. So I wanted to give him like an appropriate a credit. I think his paper, I'm giving a timeline after, but like it's like 15 years ago that he released it. And also there is not many people who actually like try to use ARM64. I know like Satoshi and Peter like managed to set up a debugger on ARM64 a while back. So whenever I worked on dump it ARM64, I didn't even use a debugger, as it was like very straightforward to recreate. Also, when you like write a program, you get a crash dump. You can just open the crash dump even without having the debugger, so it makes it like very easy to debug. So yeah, kudos for them, and thanks again for helping me to set up a debugger, because there is no like Ethernet cable or anything, so you just have USB-C ports. But actually, it just works like the same way, just like network debugging, using like a good quality like USB-C cable from your host to your laptop, and that's pretty much it. Like it just appears as a new internet connection, and that's very straightforward. For some reason, I was really expecting something more complicated, and just very straightforward to set up. A big thanks to Sean, so Zero Sum. He did a lot of work on explaining and reversing Eternal Blue and Double Pulsar. And so like a lot of his work around SMB exploitation is very helpful in general. It was here, and he's a good person I can brainstorm with for those things. Laurent Gaffier, for his work on SMB. Laurent has been doing a lot of like SMB research over the past like 10 years. I remember we invited him to speak at our conference in Paris 10 years ago, where he was basically like, he had so many like SMB bugs. It was just crazy. And I remember even at that point, I was like, yeah, but there's no way you're still gonna find like SMB bugs like that, and look at us when 2020 and there's still like so many like critical bugs in SMB actually. So on that, I was picking SMB as a target. He has been quite the pioneer. So definitely like follow him on Twitter. He is posting a lot of cool stuff. And the NSA and shadow brokers, obviously, because of Eternal Blue and Double Pulsar. I think that's also one of the main reasons people are freaking out about any type of like remote code execution in SMB because of Eternal Blue, which is pretty old now. Like the exploit itself is almost going to be like 10 years old. Like it's what, like 6 years old, 7 years old? Like correct me if I'm wrong, but that's quite a long time if you think about it. And people are still talking about it. And there's obviously like way better exploit in the wild that we haven't found yet, which is a bit worrying if you think about it, because it shows you like the gap between like defense and offense, because it takes so many years for defense to catch up on techniques and find like countermeasures. It's a bit worrying. I mean, even though like anti-phishing is still an actual topic, and we're in 2020, so imagine kind of remote code execution. Microsoft, which it's Microsoft team who found the vulnerability in the first place. Nicola Economou and Alex Ionescu for their AL research that they published. So it's quite interesting. Nikita Karatnikov, who has been a pretty big inspiration to do some work on ARM. So I've been enjoying brainstorming with him. And Suel Amu, who has been publishing a pretty interesting blog post on APCDE, so for all the event stuff, and obviously the Opcode community, and and my dog Balu, who is here, who has been the inspiration behind them. Anyway, I guess we can start now. Yeah, because one can patch stupid. Yeah, it's true. I mean, like anti-phishing, you're not patching anything if you think about it. People are like still pretty big on it. So yeah, one of the thing about it, so that's the version I've been using, so the 18.36.2 version of Windows, and even at some point, because I think overall, like I had to reboot my machine like more than 100 times, from like the different crash, different things I was testing, like just random things, And once, like when I restarted my machine, it was applying Windows updates. I was like, no way, I hope I can remove them. Obviously, I can. Well, obviously, like it's not that obvious, but I was able to remove like the updates. I was like, oh, it's like really. I felt like it was quite scary here. So I'm giving the name of the patch, actually, and yeah, let's just start with the demo, then I can explain how it works. to connect on Zoom with the other laptop to share the screen. So that's the only way I found of showing the demo. I was thinking of doing a reverse shell code, and then I was like, oh, whatever. No, I'm just gonna do like a calc shell code that's the same thing, and at least people won't reuse it, you know. So yeah, just connecting with the other machine. Give me 1 sec. And there should be here. Okay, cool. Continue. Share screen. Okay, and I think we should be able now to see my screen. So let me just move the exploit now. So that's available on GitHub anyway. Let me just like move it a bit here. So the exploit is pretty straightforward. It works the same way as it was actually. Let me just move it up. Can you see here? Yeah. Okay. Actually, maybe I can just move this guy here. Yeah. And yeah, it works pretty much the same way as the exploit from Chompy, same parameters. And then let's see if it does work. Writing the shellcode, yes. Execution, okay. And we got our calc. That's pretty much for the demo. Now we're just gonna do a deep dive in looking at what's happening here. So as you can see, a bunch of the variables here are pretty different anyway. So there's some non-variables like the AL interrupt controller and the GIC3, which is the new name for the interruption. And then for like the whole shellcode part, I'm using a completely like a different technique. But yeah, that's pretty much. It's on the other screen. It's pretty much for the exploit, and it does work quite reliably. I mean, like, look, we can punch it again, and see we get another like calc, you know. So you know that's quite nice. See that it's just working like quite reliably. I guess we probably don't need the zoom thing anymore now, but that's it for the demo. At least like we can put the demo behind us. It worked, you know. Let's talk about the technical details now. Yeah, like see like just like popping like quite reliably, you know. So that's quite nice, you know. Okay, let's talk about the vulnerability itself now. There is better blog posts. So the one from Huge Org and Zekops blog posts are like explaining, you know, like, oh, they create the MDL thing, you know, like the fake MDL and all the buffer overflow is working, etc. It's definitely explained in a much better way, so I'm not going too much over it. But for intellectual curiosity, what does an int overflow look like on Windows ARM64? So that's literally the only section about the vulnerability in this blog post. And as you can see here, so you have the add W9 plus W8. So W is for the 32-bit registers instead of like the 64-bit registers, which would be like X9, X8. And yeah, and that's it. No usage of like saved int in the kernel right before an SRVnet allocate buffer. I mean, that's pretty obvious to find. No, I'm pretty much wondering like, why did it take that long to find? Because that's quite an obvious into overflow, and you would expect like the current static tools to find it, you know, or like whatever like methodology would be used now from like vendors to find the bug, but you know, like error happens. But because it's an obvious one, I'm sure a lot of people have found it like way before, which is like the whole thing of that bug. You know, it's such an obvious one. But yeah, it's quite nice and clean. Initially, when I was looking at ARM64, because I didn't really know like anything about ARM64 like 2-3 weeks ago, I was like, what's this kind of like weird assembly, you know? And then I got quite used to it, and I do like it now. I think it's quite neat. So yeah, kudos to Hedgehog, who is actually the from all the stuff I've read, you know, is the guy who came up with the read physical memory page using the fake MDL structure. So that's quite nice and a pretty nice way to bypass like KSLR. So Chumpy used it by using another technique from Ulf, where she was trying to find the HL low heap. I tried to do something similar, then I tried to find like the actual PLM4, which is called TTBR on ARM64. That didn't really work out. I will explain in the next sections why. Actually, let me change the timer here. And yeah, I had to do a bunch of debugging around it, so I'm posting some of the comments here. And I have my debugger loaded in case if you have any questions or if there is anything you want me to verify on the ARM64 machine, so can make it interactive and fun. Yeah, so here I was just like looking at the int overflow, so the allocation, and the SRV net send data function, well, to know what was the address inside my MDL. And then one thing led to another. I wanted to understand, so the problem I had when I was using the Chumpy exploit directly on my machine initially is, well, first nothing was crashing. I was like, okay, that's interesting. And then when I was, sometime it crashed much later, and then I started to look at it, and all the data I was getting was the K user shared data stuff, regardless of the physical address I would put inside. So then I started to wonder, I was like, well, it's just reading a virtual address. It's not reading the physical address at all, like I was promised. I was wondering if the behavior was different on ARM64. Then I saw also some issues on a GitHub repository where people were complaining, saying, oh, the read primitive was failing. And then I started to look at the MDL flags being used. So, and I ended up using the 5018 flag instead of the 51C, which is removing the MDL source is non-page pool. And the reason I ended up removing that one is while I was looking at the code, and you know, I started to like remember about the get system address for MDLSEF macro. So even if you see it in the code, you will not see it because it's a macro. But there is always those checks on the MDL flags, checking if so if page pool, so if the flags are mapped to system VA or source is non-page pool, then it would use the map system VA. If not, then it's using map log pages specified cache, which is what we want to be triggered because that's where it's gonna like start to read the actual PFN of the MDL. So when I started to see that, I was like, oh wow, actually that's interesting. And then I was like checking the flags, I was like, well, the MDL source non-page pool flag is present. What about I just remove it? and I remove it, and it worked. I could read like physical memory. I was like, oh wow, that's good. Except, okay, like it comes with some like terms and condition, you know. You can read physical addresses, but if the physical page is not visible, you know, if it's not actually mapped, you know, if you're like asking for a random like physical address, it's either gonna hang or you're gonna get a blue screen. And also the other reason is if you cannot lock a page, which is what I suspect is happening with like the page tables. And we're gonna see like in the next session why it's a bit annoying, but you're gonna end up in a similar situation with hanging and or crashing. So, and actually it reminded me like when I initially wrote dump it, you know, like everyone was like, oh, like doing a digital forensic, like we want like raw memory, this is what it should look like, we want just like a raw dump, we want a vmem type file, you know. So everyone was reading from 0 to the highest physical memory address, and that's was the idea of like raw dump, partly from like law enforcement, you know, being like, oh, we use NKs, we use raw dumps, we load it in NKs. So it was the mentality and it's still around. But it was having a lot of issues, and rightfully so, because you have physical address space and RAM, which is two different things, and physical address space as the RAM plus the memory used by graphical devices and all those things. So if you try to query the memory of another device, you would get a crash, or it would hang, and then in my presentation, like blue screen of death is dead, I was explaining like the basic things about like what's physical memory layout. And there is a very interesting function in Windows called mmget physical memory ranges. Actually, it's funny enough because my old blog, I didn't renew the domain like a few years ago, and but I managed to retrieve that blog post on the Chinese website. But yeah, that function is giving you like memory ranges, and we'll use it like later on in the blog post, you will see. And you know, like the physical memory runs and descriptor are the actual structures that give you like the memory ranges used by the RAM and at which physical address they are inside the physical address space. So that's something to definitely keep in mind. And also the second reason, because I was wondering, I was like, oh, okay, like how come I cannot read like none of the page tables? Because initially I was like, okay, like Jumpy is getting like the PT, yeah, like thanks to our Chinese friends for making backups of my blog. That blog post is like, I don't know, like 12 years old, you know. So that's pretty cool. Yeah. And then I was like, okay, I'm like, Chumpy is using this technique, which is like reading a page table, trying to find a self-reference to the PML4. Okay, and then like you can get the virtual address to override the care shared user PT, which is something I was doing manually in the debugger for like the longest time, until I was like, I'm kind of annoyed to just like tap the command to know like, okay, what's the virtual address of my PT, and because I was not able to read it from the exploit, right? And there is something I read in the documentation, so I put the link here, so if you want to read more about it. On ARM64, and I don't know if this is the case with all the ARM system, you can have multiple physical address space. So you have the secure or the non-secure physical address space. They may or may not be the same. So that's something to keep in mind. And I was like, oh, actually, that's quite cool. So both worlds do not always have the same physical address space. So at this point, I don't know if when I was in EL1, which is like kernel mode, I was in secure, non-secure mode, and if it was the reason I could not read the physical address space, because when you're using Windows Debugger, you can actually read those page tables. So I was like, I don't get it. This is definitely a TIS address, you know, like what's going on? And yeah, so so that's the two hypotheses. Either it's not mapped or it's locked, so you cannot just like relock it, and just like a separate physical address space. So there's a few things here. So whenever you want to retrieve the TTBR one address, you can use the PCR structure, which is quite nice actually. Let me just show you here, or you can. Oh, I'm typing on the wrong screen. So you can retrieve like the actual structures and address for like your main page tables very quickly. So let's look at the PRCB and then process state, and then we have this one called arch state inside the processor state, and that's where we get the address of our TTBR. It's like, so that's the main one. So we have the so EL1 kernel, and then we have the secure and non-secure ones. So that's how we can look at it. And then, you know, if we actually look at it, you know, we can actually read it inside Windows Debugger. But if we look for that same physical address, and yes, there is an 8 at the beginning. We'll see why after. Yeah, there is that's not readable from the exploit, although that address does exist. And another like variable which is interesting, which we'll use in our shellcode, is vbar EL1, and vbar EL1 is the ARM64 exception vector. Bruce Deng actually wrote a pretty nice blog post about like how it worked. I found it after actually, when I was like trying to search more information about vbar EL1. But yeah, so if you're coming from x64, TTBR0 is basically like the equivalent of like the PML4 or CR3 register. That's like the main thing you need to remember. And the interesting thing here, first, a very interesting thing we're gonna find out is on my machine, the page table, so for like the TTBR PFN, has consistently been that address. I've been rebooting it like more than 100 times. Like 50 is a very conservative number given the time I spent on this. And even if you look here, I just tried again, it's the same value. So I'm not saying it's static across all the machines. I'm just saying it's static per machine. So if you know it once on a machine, like very likely it's always going to be like that, unless like some changes have been made like recently, which I'm not aware of. Yeah, that address is quite consistent. And here, let me check, does it work? Yeah. And from debugging the actual bootloader, so if you look the call right after, so boot mg fw module, so there's a function called ARM64 pallocate and initialize page table, which allocates like the main, you know, like TTBR that returns TIS address. So to understand how the address is being computed per machine, or to do some prediction, like I or we would need to look at that specific function and what's the logic behind it. But I didn't have time to do it yet. But that's basically where the answer would be if we would want to know the exact answer of why it's static. So initially when I saw that, I was like, well, that's quite nice. We have like a TTBR, which is static. So I should be able to read it and find the self reference to the TTBR, so I can get the, like the virtual address and then find the virtual address of the PT I'm interested in to like flip the NX bits, right? But like I was saying, like it didn't work, So at this point we have two main assumptions. KSLR is only used on kernel virtual addresses, but it does not seem to be the case for early physical addresses. So we have KSLR for virtual addresses, but not for all the physical addresses. The second point is, but unfortunately, we cannot read physical page tables. Well, let's think a bit out of the box here. What's the other PT that's created very early that we would be interested in? What about AHLP interrupt controller? Well, guess what? It worked. I was like, oh my god, that's crazy. So here the PFN is always like 80009 on my machine, and that has been like very consistent across a few machines that I managed to look at. Unfortunately, they were the other ones were patched, so I could not like have tried the exploit. But so the terms and condition here is, so the exact answer is, okay, the static address is not always like 8009 as a PFN, but the logic is the same. So where does it start with an 8 in the first place, right? Like where is it like 8000 or like 80,000? So the reason it is 80,000 is because if you look at the actual like physical memory descriptor I was talking about early, like here when I was talking about that function here in my blog post backed by our Chinese friends, the actual physical memory descriptor here in my case start with 80,000. And on my friend's machine, who had a completely different laptop from a different brand, it starts with 40,000. And then, so you just take the base page of the first physical memory descriptor, and even here, like let's look at it. So see, it's like it is like 80,000, and then you can see like the other ones, like it's mapped completely differently. So it is the base page plus 9, and then you get your PFN. So in theory, and I tried in my case, I was like, okay, what happens if I try to read that physical address on my machine, and then the one that I know is valid. So when I tried to read this, I got a blue screen, it was hanging, because initially I was like, well, in that case, if I just need to try like 2 physical address to get the interrupt controller like PFN, like that's definitely worth it. But if you get it wrong, like it's gonna crash. So it would have to be like brand specific or like something like that. But I'm sure there's like better ways to find it. But that's basically like the logic behind it is whatever base page you have plus 9, and then you have the PFN of the or like HAL interrupt controller. And then if we look here, because we like nice things, it does look familiar, except that instead of the APIC functions, we have the GIC interrupt functions. Yeah, actually, like I can show you here the logic of what's going on here. But if we look in this function, so read interrupt controllers, that's basically where I'm reading sort of like my physical address, which is a fixed address. I read it. I do some like very simple heuristic at this specific address, which is here. So here I know it's a size to verify the actual structure that it is the right structure. And there's few informations I want to retrieve here. So first of all is the actual virtual address of HL interrupt controller, because we're gonna need it when we're gonna patch one entry in it. The original address of the GIC3 request interrupt, because that's the entry we're gonna patch. And yeah, and its virtual address. And and that, yeah, and that's the second. The last information we do care about is the HL virtual address. So here I just make a subtraction because I'm just taking the virtual relative virtual address of interrupt controller, because we'll see why in the next section. So that's the heuristic I was talking about. So here, static, verify the address. We do care about the base address of HL for later stage. So that's the offset, the delta I'm removing here. And so what I was saying is APIC does not exist on ARM64. So one of the things which is different is APIC is replaced by something called generic interrupt controller, and there's multiple versions. The version implemented here is 3. I think the latest one is 4. And so yeah, it defines how to handle all the interrupt, obviously, and it can be uniprocessor or multiprocessor. In our case, we're gonna patch the request interrupt entry just to be faithful to the APIC version where we patch the APIC request interrupt. If you call IO remap to create a new mapping for RAM, won't the multiple mapping have different attributes? I don't know, but if you do know the Windows equivalent of that function, I may be able to answer. I'm really bad at Unix stuff. For the push pop instruction though, we're gonna see this quite soon. It's the section right after, because I'm gonna be talking about the shellcode part. But first, we're gonna see we're gonna bypass KSLR here, and the non-execution also. So there's two methods here that we're gonna see first. So yeah, so K-shared user data is a popular option to compile and execute payloads because K-shared user data is a fixed virtual address. And so that's what I was saying, that's what I tried initially. I was like, okay, let me look at it, I can retrieve the PT. So just hard coding the PT, just from typing the virtual address. Yeah, and taking the value in it. One notable thing though, in case if anyone can find a technique for that later on. So what we do care about are those two entries, because the PT format is similar for reading page frame numbers, but not for the other flags. Actually, they are very different. So there's two PT that we care about is privilege no execute, which means no code execution in kernel mode, and user no execute, which means no execution in user mode, which is EL0. So if you flip those bits, which is basically what I do here, you put both of them to false, and that's it. In theory, your PT will be executable. But like I was saying, remember, we cannot read physical page tables with our MDL assisted physical page read. So I was doing that technique like with the help of the debugger, you know, like I was like finding the PT and everything. So it was pointless because we cannot use it in practice. Then I started to wonder, I was like, why would I even like try to do like everyone and just use like a shared user data when I'm sure there's a better way of doing it. So why trying to find a PT and flip it just to execute code? You know, I'm sure there is like other like pages we can use to put our code, you know. And then I started to look at the base image of kernel modules. And one of the things I noticed is, well, they're all executable. And why? Well, I'm even making jokes in that blog post, you know, it's getting serious here. So I love big pages, but I cannot lie. Why? So because the binaries are mapped over like big pages, and you know, like the header page is not on a 4K page and then binary on a big page which is executable. The whole binary is executable. So if you take the code of the binary or the header, it's gonna be in an executable PT, which is quite nice. So what I ended up doing is, remember like here, I was saying, okay, we do have the virtual address of registered interrupt controller. So we can retrieve the actual base address of the HL module. So you see here, we get the base address and yeah, with the base address of the HL module. So that's quite nice because now we do know where we can copy, yeah, and here, you know, I do check like the PTE, you know, and as you can see, not executable. Well, no, it is executable because the non-execute flag is off. So if we just put our shellcode at like HL plus 500 because I didn't want to overwrite the original header. Because also imagine you overwrite the thing to write your shellcode, and then with your shellcode you try to read the export table, you know, which was overwritten by your shellcode, you know. It's like, so that would be quite stupid, right? That's one of the main reasons also we don't do it. So yeah, so we do know where we can copy our shellcode. We don't need to do any like PT, like non-execute bit flip. And we do know what we can patch to get the initial like jumper for the code execution. So now we're getting the shell coding. So and this, you know, I didn't have time to try it on 64-bit Windows, you know. I would be definitely interested. But it's quite a neat way of like bypassing KSLR and you know, like execution. Well, non-execution, I guess. So the first thing about our shellcode is, so there is no push and pop, like someone just said in the chat. So Destructive Research Labs. That's quite a long nickname to read, you know. Like I have to focus. Indeed, but there are registers, and a lot of them. And also one of the registers which is quite interesting here is the link register and the frame pointer one, but the link register, so every time you do a call anyway, that value is going to be registered. So whenever we're going to want to exit the function, we want to make sure that especially that register is set to normal, to the original value. Otherwise, you know, whenever it's going to hit a write instruction, it's not going to return to the write instruction, and you can end up to some sort of like infinite loop, you know. But it would crash like way before anyway. So to re-implement a push add and a pop add on the ARM64, so that's how I did it. So I created like a fake frame on the stack. So you know, like very straightforward way, you know, like just allocate the space on the stack and store all the registers from X0 to LR to the stack. And when you want to read them at the end of your shellcode, just restore them. That's your POPAD. So instead of having like a 1 byte instruction, you end up with, I mean, like 4 bytes, you know, per instructions. But you know what? Because of this, we have like B100 like byte of space anyway for shellcode. So why not? You know, like why not? What else? What else do you need? You know, like even at the end, you know, like that shellcode could be like even like much bigger because it's a lot of space basically. I can probably put like some demo making video in it instead of like a calc, you know. That would be a new type of demo. So we have a pushad, POPAD. The next step is, okay, how do we get the address of the current process? So also there's something interesting happening with the X18 register. So it has 2 names. So in Windows Debugger, they would use that notation, which is, I mean, I prefer that one because it's the least confusing because all those like registers sound the same. Or the IDA notation, which I'm not a big fan of because it's very confusing, and same thing for like the, you know, like the MRS and MSR instructions. It's much easier to read on Windows Debugger than on IDA. Because this on Windows Debugger, as you can see, okay, like you can see what's going on here. But in IDA, you would see like C0 or C2, like unreadable. So it's quite confusing. But anyway, so XPR in kernel mode is pointing to the KPCR structure, so we can just like read it, get our thread and process. And in user mode, it's gonna point to the TEB, which is also something we're gonna use for our user mode shellcode. And once we have like our current e-process, then we can obviously like walk through all the process to retrieve the kernel base address. So we're gonna use that register I was mentioning before, so the vbar EL1, so the Victor base address register for, and as you can see, it does say, you know, like EL1, so that's the version for the kernel, where we get the KI ARM64 exception vector function. So for all the exceptions, it's going to go through that function. Bruce Deng wrote a quite nice blog post actually about it. So yeah, he was explaining like, although it's not really relevant for the shellcode, he's kind of explaining. See, that's the notation I was talking about from like IDA, or this, you know, like it's I mean, I don't know, like like look, even see, like just to like it in Windows DBG it would be like MRS X1 ELR underscore EL1, you know, like, okay, like you kind of know what's happening, but like look at this, like 0, like C4 0, like 1, you know, like I mean, definitely needs some macro in IDA to understand this, because like let's say we look at it now in WinDBG. See, okay, the first one, it's like MRS XPR TPIDR underscore EL, you know, okay, like that we can understand. Then you have like the IDA version, which is like X18, you know, instead of XPR, and all those things behind, you know, like they're very confusing. Definitely not very user friendly to read. Same thing. See, like same thing for like ELR. They like all those registers here. You know, like it's very hard to read the IDA notation for that. Very hard. Which is funny because if you use the Windows debugger notation anyway and compile it with your compiler, like your assembly compiler, it will work anyway. So I mean, I'm sure we're gonna see an option in the future, but I do hope so because it's unreadable. Anyway, so to get the NTOS kernel base here, so we just get the exception vector function address, and you know, we clear the bytes, which is what we do here. And yeah, we just like subtract the base from it, and that's it, and we work backward. And we check the signature. If it's an MZ, that's it, we have the base address. Another interesting thing also for the shellcode, which is ARM64 specific, is they have a bunch of CRC32 opcodes. So that's quite nice, especially when you want to hash functions, because instead of doing your own hashing function or whatever, so in my case, I was just using my own hashing function, which was using the CRC32B like instruction. And yeah, so I have this clean way of like hashing like function name, and that's pretty much it. Another cool thing also is, and I got the idea from brainstorming with Zero Sum, is so if you look now, all the Windows like kernel shellcodes, they all use like APC twice, and even like Suelamo actually like wrote this nice blog post actually last year about it. Was it last year? Yeah, last year. Saying, oh, like ATP is using ETW to detect user mode APC injection from kernel mode. It's a good blog post. I would recommend you to read it. It's quite straightforward. But yeah, so there is an ETW event to trigger like this, and actually also like Huge Hog mentioned in his blog post that he had to patch one of the function from from kernel mode, but in user mode, which was the NTDLL equivalent, which is here. My kernel on shellcode is a very orthodox one, APC twice, didn't work at first. While writing the kernel shellcode, I found that the user CFG recognized the APC call for user-alone shellcode as invalid and intercepted it. As you can see from the screenshot below, KI user APC dispatch calls LDRP validate user call target before jumping into the user shellcode. So there's potentially like two annoying things that we don't want to have to do, and you know, we don't want to have to look for like the NTDLL function and patch this function, you know, like he had to do, you know, like, you know, we can patch the function. It's actually quite nice that he shared that, because that's the first time I heard about it. So that's also something I wanted to be aware of. And I was like, yeah, you know what? I'm just gonna like try to see if there's a better way to do it. And if you look even at the APC like injection in user mode, it had been like, people have been using the same thing for a very long time, since 2005, you know, like when Barnaby Jack initially published it. I did write about, you know, like kind of like the blind spot of some EDR, because a lot of the EDRs now anyway are like relying on the ETW events. So I was talking about the history of the APC techniques, how it kind of became more popular for injection, and or like we are detecting it, or we're like doing some different type of detection for like such things with our platform Stardust. But yeah, like everyone has been using it for a long time, kind of like annoying. But the good thing is with Windows 10, there's this API that appeared, which makes our life easier. Exported by the kernel this time. It was always exported by NTDLL, but now it's exported by the kernel. It's called RTL create user thread. So now guess what does it do? Yes, it's beautiful and it does work nicely. I mean, I've been laughing during the whole time I was writing this exploit, because I don't know anything about exploit. I just wanted to learn ARM, you know. I mean, I read stuff about exploit, but I don't write exploits. Zero Sum also wrote a nice blog post about ring zero escapes. It didn't cover that one, but I did try it, and I didn't try it on x64. I tried it on ARM64. It worked fine, you know. I'm pretty sure it works on x64 also, because it's also exported. And the way it works, so that's the actual like pseudocode of my my shell code. So you don't have to read like all those crazy like registers. So I use one APC once to get out of that super high like IRQL, you know, and just like resume back the execution, you know, to the normal state, you know, because I don't want to stay in that IRQL mode, and I don't want to change the IRQL in that specific mode to avoid any problem. And then to lower my IRQL, so here I could have hard-coded the actual like RQL change, you know, for like to go from to passive, you know. They just overwrite it in the PCR. But since I had the base address of HAL, you know, I was like, you know what, I'm just gonna play safe. I want to do something clean, so I'm just gonna call like kf lower RQL and kf rise RQL just to like have something nice. Then I use like k stack attach process to be in the current e process of my target process. I just decided to allocate, you know, like just a nice like 1000 you know, like one page in my user mode virtual address space. For the handle, I just use -1 because we did the stack attach process. We don't need, I mean, I've seen people like doing that where just like, you know, like do like the NT process handle and pass the handle. Like, doesn't make any sense. Yeah, then I just do like an homemade memcopy, and then I call my RTL create user process. What else do you need? I was like, what else do you need? So on x64, you know, like shellcode, you see like STI, CLI to enable and disable interrupts. You can do that the same way here. I mean, I just used it only when debugging, but now in the version you saw, you know, it's not a version that I want to debug anyway, so just removed it. Because it was not necessary. And after we call our popad, we just pass the execution back to where we want to go. And so, yeah, the equivalent of a jump, you know, like registry is BR x8, and the red never gets executed anyway. And because when we did our pub add, we restored the LR register, which is the return address, then we were good to go, you know. Actually, let me show you the actual. I mean, you can see it on the. If you go on the GitHub, anyways, is the full shell code, you know, which is here. Yeah, here are some notes, you know, that I had before. See, like that's the push add. That's the internal base address, you know, where I keep saving all the, you know, functions and values that I like and want to use. So like the base address, the process object, Same thing for like the other objects. The single APC we are using, that's the hash for all the functions and process. Yeah, and that's pretty much it. Like if we cannot allocate the memory, like it fails nicely. No, yeah, and that's yeah, overall that's pretty much it. That's the get process address, which is exactly the same one in user mode. So if we look at the calc shellcode, so same thing. It's gonna use for the hashing like the CRC loop that was mentioning with the CRC32 byte instruction. Yeah, calling our function here. I didn't put a full like per chat per pad, you know, because whatever, it's like in user mode, and that was fine. But yeah, that's pretty much like the same way. It's more compact than the actual because initially I was like allocating a small stack and everything, but at the end I'm not even like doing all of this. I'm using a much more compact version. And yeah, that's pretty much it for like the user learn part. So remember, like x18, which is XPR, is pointing to TEB in user learn and the PCR in kernel mode. So once it's being executed, so we are in EL0. From the TEB, we can access to the PEB, and then from here we can just like work the DLL just like a regular shellcode. And yeah, and that's pretty much it. So pretty stable overall. Like the KSLR bypass, because there's no like physical address, SLR is working nicely. No need to patch a PT. Yeah, overall it's pretty nice. Conclusion here. Memory forensic is dead. Long live to memory analysis. I stopped calling memory forensic. I just like call it memory analysis, because at the end of the day, all the things you have to do now anyway, like if you want to find like like stuff in memory, like let's say that's HL. I mean, in theory, like we should find our shellcode here, right? And here is our shellcode that was executed, is still in memory, right? So you can see like the post exploitation detection for it, because obviously, like I was saying, like the goal of that blog post is to be educational, because it's interesting to understand techniques, but at the same time also to understand how to better detect. So here in that case, because the interrupt controller entry is going to be repatched right after, right? So unless you do clean your shellcode right after, it's still going to be present in memory. And here, as you can see, that's our stack frame. And all those beautiful operations we have been talking about, even here we can see like we're trying to retrieve the either the NTOS kernel address base or the HAL address base, but I think it's probably the NTOS kernel address base, because yeah, we do have HAL already. And yeah, I mean, and all our get process calls here with all the hash and everything. Yeah, I mean, it's quite nice. Like, so that's why I just call everything related to memory and detection and defense like memory analysis, because it has nothing to do with what people like call memory forensic. It's so far behind. I mean, I was saying it at the beginning of the article, people are still stuck with like the row dumps and all those things. It does not work for like modern attacks. For instance, here, how do you want to detect attack on ARM64? Nowadays, like as far as I notice, is like the first public exploit for Windows ARM64. Now there's like Surface laptops being popular now. You can't. A lot of like those tools don't even work properly with Windows 10. So let alone like ARM64. Although it's not as popular, it's gonna be the excuse that people are gonna say. But like I don't think it's an excuse for defenders to be like behind attackers all the time. So that's why I still think it's interesting to like look at all those aspects. So in that case, one of the things I've been pushing for is like, at least if you can get like a post-exploitation memory dump here, while you can still like retrieve the shellcode like we just saw, like, and there is like different places where the shellcode can be like in place, like in the case of the Chompy exploit, you would see it like in cache-shared user data plus 900, because that's where like the fake MDL and like shellcode and everything are being copied. So but yeah, that can be in different places in memory. So that's why having like an actual like like Microsoft crash dump, which is like what things like dump it I mean are generating, or if you get like a blue screen of death, then you can get a memory dump. On Linux, we've been doing a bunch of research on Linux. Yeah, same thing, like we're using a like elf core dump for like full memory. And on Linux, I think it's even more interesting because a lot of like the actual like even like the EDR detection, a lot of research is done for like Windows stuff. On Linux, there's like almost like nothing. There's few like Linux presentation that we accepted for Black Hat US this year, so that's interesting. But if you look at all the cloud servers, most of the things are Linux. And the only thing people are talking about is like anti-phishing products because of like BEC stuff, or like how to use like OS query for incident response, and we're in 2020. So I mean, it's a bit depressing, but I mean, I stopped trying to like even like get emotional about it, because whatever, if people think like OS query is gonna protect them on their Linux machines, when they cannot even like investigate like post exploitation like techniques or anything, yeah. So if you do like Linux exploitation, same thing. Like I'm sure like people will not find anything at all. Whereas like here, even on ARM64, like you kind of like make a short list of places to look at, make some playbooks. At least that's something we're attempting to do like internally. So it could be like detection playbooks and detect them. Well, you can find stuff after a while when things are not supposed to be there, right? But yeah, that's pretty much it. And I think it should be, I mean, like obviously, like I was saying, is like for ARM64, like no one does any detection for it, like EDRs when you're announcing like endpoints now for Linux. They're quite proud of it. But if you look into details, even if you ask like a lot of their customers, they're like they know it's shit, but what do you want to say? But yeah, it's kind of sad that defense is just like kind of limited to like converting like IT tools into like DFIR like utilities, but you cannot really convince people that whatever they have learned is a bit useless and not how they should be doing things. But yeah, so that's pretty much it. Although I hope I was not too much of a downer at the end, like didn't mean to be depressing. But yeah, everything is on GitHub. Even the full blog post actually is on GitHub. Looks quite nice actually on GitHub. In case like if my website shuts down, and you know, some Chinese friends want to do like a backup of some of my articles again. At least it's on GitHub now to be easier for people to do a git clone. Yeah, the full exploit is here. The kernel shellcode, the user non-shellcode. Yeah, if you look at the exploit file, you would see like most of the stuff that are being described here. And yeah, and that's pretty much it for my presentation. So if you have any questions, you're more than welcome to shoot them. Otherwise, if you have no questions, you're more than welcome to join us on the Discord server. So we're always there. How long of a period of time did it take this for you to? I would say around 2 weeks, 2 to 3 weeks. Because I started a bit before the other like opcode. I was kind of like, I was hoping to finish and everything. Yeah, and I finished like 1 week later. So I would say like between 2 and 3 weeks from like learning how to set up like the debugger, learning ARM and all those things. But yeah, it's quite interesting. Like I was saying, like ARM actually, I didn't really like it at the beginning. I found it very confusing because I was so used to like the Intel syntax. But it's quite nice actually. I do like it, and yeah, I'm also trying to learn a bit more about like embedded device because all of them are ARM. It's not ARM64, but you know, like I do feel like IoT is definitely gonna have an interesting like space. A millimeter this morning actually, but yeah, I think there's lots of cool stuff to do research wise, you know. But yeah, so you guys are more than welcome to join the Discord. If you have any questions, you can shoot a message on Twitter or just like come join on Discord. You know, we start to have a pretty good group of people. Like it's kind of like a close group. Like we're not that many, we're just like few hundreds, but most of the people are like really good researchers or like, you know, like teenagers who want to learn more about security or like IT and all those things. So it's a good mix of people. Everyone is behaving like nicely and everything. It's just like I'm just trying to recreate like the atmosphere of like IRC like 15-20 years ago, you know, when it was nice, you'd ask questions, you know, like you, although before, like we didn't have like Stack Overflow and all those things. But I do miss like IRC a lot. I do feel like it's quite an instrumental place, you know, when you want to ask some things or like look for a job or all those things. So yeah, subscribe on the YouTube channel and come join us on Discord. And yeah. If you have more questions, yeah, don't hesitate. I'll put some background music. Actually, I don't even know if the music is working. So that's it. No more question. I guess this means that this is the end of this live stream. So also, if you do want to present for the next opcode, the call for paper link is available on the website. You're more than welcome to submit. So this is edition 8. We have 9 and 10, and I think after 10 maybe like it's time to take like a bit of a break for a bit. And there's like more like cool presentations, but yeah, and yeah, just like at least you know that all the links are available on the GitHub. For the other presentations also, I'm gonna put the resource also on the GitHub. And thanks to our speakers today, so Grok, Corentin, and Paul. But yeah, that's pretty much it. No more questions, no more comments. I guess it's time to let you go, so I can get some food. Getting thirsty here. It's like 40 degrees in Dubai. Okay, guys, take care.